Okay. So, I started a little bit of work on this. I'm going to make a first-person example for the 3D physics where you can walk around a little world. Because I feel like the best way to test the physics is to try and jump through walls and things yourself. So I made this tiny little level. It's really simple, but it's just supposed to test exact like mesh collisions. I'm thinking I'm gonna do some other detail here, but right now this is just multiple platforms to test accuracy of the player standing at different heights and make sure it's aligned. This is the other thing. I'm thinking of not doing it in first person to begin, so that I can test accuracy correctly. Like, I'm thinking just dropping some particles here would do pretty good as well. So I might just do that. So this is the example right now. I basically just took the 3D physics example we did yesterday, and I just added in a tiny procedural terrain. So I think, yeah, I mean, I have this sphere mesh, I have the particle class. I think, yeah, I'm just gonna drop some particles on this. So first of all though, we have no mesh collider. So I need to program our mesh collider, and I've been thinking about how I'm gonna do this. I have a system called custom distance for called custom distance, and that just lets you do anything like a custom mesh. So I'm going to be making the mesh collider as a custom function for the existing collider, and I think I'm going to organize these in separate folders. I don't know. Or I might just include, I think I might just include the mesh collider in Physics 3D. Because on one hand, I feel like it's something you'll use basically everywhere. I don't know. But then the other thing is I also am thinking of doing more custom colliders, and I kind of want to put those all in a file together, and that's why I'm thinking of doing a Physics Colliders 3D. I don't know if I want to call them custom or extra. I don't know what to call the file. I guess maybe just but yeah, I'm thinking about how I can do this and how I can optimize it. So, got this thing called the max unit size, and this is like how big an object can be, and this tells you how far you actually need to search across like an area, because you can never search, like basically if you make your search hierarchy like the bounding volume with like a lookup table not able to support big objects because your table cell size is too small, then it won't work. So I'm thinking about like optimizations I could do related to this. Like I'm thinking I could just return the mesh bounding box. I don't know. Anyways, to begin, I think we're just going to do brute force mesh distance. It's literally just going to search through, and it's just going to find the distance to the triangle. Which is going to be brutal performance-wise, but I thought, why not? I think it's a good way to test it. So there's 800 triangles in the terrain. It's going to be looping through 800 triangles and doing the distance function for that, which is going to be pretty bad, but that's why we'll look at optimizing it. And anyways, for small meshes, a bunch of small meshes that have like 20 or 30 triangles, this would actually be awesome. So it's not like this is completely useless either. I'm just thinking, how do I want to organize this? Because it's going to be custom distance, probably have custom normal too, and the custom data is presumably going to be this object. I'm going to mark this as a constructor for closure compiler. Wizardry. We'll see about that if it works. I don't know, I mean, I guess a lot of wizards have failed spells, so that's also true. I'm just listening to the noise on this camera outside. It actually sounds like something is on the camera right now. Who knows? We've had an owl out for a while now, and I've just been waiting to just see an owl just swoop down and just pick up the bunny or some of the birds, like. I don't know. Maybe it has mice to eat around here. I'm actually super curious. Do owls hibernate? I'm pretty sure they do, but at the same time I feel like they're not big enough. Oh my god. Owls... Owls migrate. Huh. I don't know why, but I did not think owls were the type of bird that flew like all across the country, but dude, it's badass to think that birds just like go on fucking vacations each year across the globe. Like, I feel like humans don't appreciate that enough. Like, man. Maybe we're just jealous of them. We don't want to like make it seem like birds are better than us. I'm just thinking how to provide this function, because I need to have it like XYZ data CMesh. I don't know. I think this is a good format for it. So I think mesh is also going to be people do also they're referred to snowbirds. True. I think I'm just gonna let this be just a regular mesh object. I don't know, maybe. Should I do this with indices or with vertex data? I guess it's always gonna have indices. Maybe I should no, I should support both. I should support both. do I do for my compute bounding mesh? Because this should be a similar thing. Pass in the data, elements per vertex. Okay, yeah, I need elements per vertex. I know less than nothing about code, so don't ask me. Yeah, I don't know. It's kind of half rhetorical, half not rhetorical. I'm kind of asking myself. But at the same time, every once in a while, people do surprise me around here with coming in and answering stuff, so that's cool. A mesh is a 3D model. It's defined by a bunch of points called vertices in 3D space. And then those points are connected into triangles using these things called indices that are the indexes of the triangles in the list of data. It's pretty complicated. So at the beginning, I'm going to make this really unoptimized. I'm not even going to do any optimization. Did that Unreal demo blow your mind with all the triangles? No, not really. Most people in the dev community think that stuff's just super overhyped because, like, basically all the engines at this point, Unreal Engine, Unity, and like CryEngine, now like Amazon Lumberyard, have all come out with like these insane demos that are like, look, it's like a movie and how high quality it is, and then all the devs are like, yeah, we know you guys have been flaunting this shit for like 10 years and it's been too slow to actually use in games. It won't be implemented for a while for sure. It won't be implemented for a while for sure. See, I don't know, because a lot of the stuff that they demoed in the past, like the voxel global illumination, it was like available in like the beta builds of Unreal Engine in like 2014, right after they announced it. And what's really weird about like Nanite, the thing they're doing to support all those triangles, is it's like they've released absolutely no info on what it actually is or what it's doing. Like, a bunch of people are still speculating on whether or not it even does the meshing on the GPU or the CPU. The way they import files will make game creation so much faster. I don't think it's all about faster, though. I think that's the reason we see so many janky games on Steam and things that are just halfway finished, is because game devs and companies just try and rush to the finish without actually providing a quality product. It's like, it's more about getting it finished and providing some tangible project to show to shareholders than actually getting results of like fostering a game community. So I need to do this differently if I have indices or vertices, because with the vertices I can just loop straight through the vertices, but with the indices I have to loop through those first. EA pushed all their games back, releasing a broken mess every game. See, what games does EA release that are really broken, though? I don't really pay much attention to AAA game devs. I think AAA games suck, man. Like, big companies push out shit these days. It's all like microtransaction-filled garbage. Wait, EA is who does FIFA, right? Like, I'm thinking about the right EA, right? Nah, man, real games these days are on itch.io. They're not on Steam. Okay, this is gonna be the really slow part. Hold on. Alright, how do you say IQ's name? Inigo Quiles? Dude, this is one thing that really annoys me. Is I don't know how to say IQ's actual name. You know what, let's ask Google Translate.
Inigo Quiles.
Inigo Quiles. Oh my god, okay.
Inigo Quiles.
There we go, Inigo Quiles. So we're gonna use Inigo Quiles. Inigo Quiles's triangle distance function. I'm fairly certain that he has a triangle distance function. So that's a regular polygon. That's really cool. He's updated this a lot. I was looking at this. I think this is almost like point and polygon. Triangle exact. Is there a different version? Is there just this? Wait. Signed triangle? No, this is not what I'm talking about. This is not what I was talking about. I guess this extends to 3D, but I could have sworn there was a 3D triangular plane here. I might have to go into some really old code if I can't find this. Oh, you're right. He separated the distance functions into 3D and 2D. I did not realize that. Good call, Namori. I did not realize there's now 2D and 3D SDF functions. I'm pretty sure he just had one before, just SDF. Bounding box, that's a cool one to add. Okay, where is it? Triangle exact. Here we go. Yeah, so this algorithm is brutal. This is what we're going to be doing in JavaScript. Jesus Christ. So doing this for every triangle, I think even with like 40 triangles, this is going to be slow. Yeah, let's I was thinking if I should even worry about optimizing this at all to begin. So we loop through all of the vertices till we get to the end of the vertice array. We have our stride here to increment that. I'm just thinking if it's worth storing all these points like A, B, C in a buffer first, or just reading them, like, or storing them in local variables so I can really quickly access them here, or if it's worth just reading them from the buffer I actually think just reading them from the buffer because it looks like you don't really use A and B much at all. You do B minus A, C minus B, A minus C, and all that. So yeah, I don't think it's worth. I don't know. Let's let's do all these by hand. Jesus Christ. I'm just trying. My brain is trying to like absorb this function and just see if there's anything I could do to optimize it. I don't think so though. And I just realized this is .2, which I think is just dot the same thing. It's just dot. Yeah, it's just the object dot itself. Okay. Gonna be Blender ray tracing. Does Blender... I know Blender came out with Eevee. Isn't that not even a ray tracer? I think RTX could help Blender. Blender's something that could use RTX probably. Screw it. I'm just gonna read out all these variables. Or should I? Yeah, screw it. I'll do it like this, and then we'll try removing this afterwards and see if it makes it faster. But yeah, we gotta read all the XYZ points of the vertices. We need to apply. This is separating, I believe this is very similar to the point in Polygon. It's separating the triangle into the 3 planes and sort of doing intersect on them. Or like, if you know like the intersect constructive geometry operation, like intersects the 3 planes to create a triangle. And I'm actually thinking I don't need to calculate these like that. I don't know. Man, this is... when writing, expanding this in JavaScript is going to be huge. And I gotta be really careful because if I do one of these wrong, the whole thing isn't gonna work. Okay. So now I don't know if I'm gonna inline cross product. That's it's kind of, I mean, it's not that big. The code for cross product is not that big. So my cat decided to lie like right under my feet, and it's like, then I disturb it when I sit up or move my feet, and then my cat's like, why did you wake me up and disturb me? It's like, you sat there. Come on, cat. It's just trying to mooch some pats. That's the thing. So let me see. This gives the normal as well, which is actually really nice. This actually means that this actually can double as a normal function too, not just a distance function. Yeah, I don't think it's worth calling a function just to do cross, especially when I want to optimize this as much as I can. It'd be really cool if V8 or some of the JavaScript virtual machines somehow figured out how to do like SSE and simd, and it saw that I'm doing a whole bunch of vector adding and multiplying, and it just put these into vec4s. That would be beautiful. Except, you know why it can't do that? Because JavaScript numbers are custom and have to be 64-bit or like 58-bit or however many it is. That sucks. Alright, BA. Let's see, BA cross AC. So this is kind of confusing because I gotta flip these around. So BA and AC. Dude, writing out vector cross products and stuff by hand, holy shit. I hope this is worth it. I think it will be, because this should just work. Okay, there's our normal from cross product. I think he normalizes that. No, he actually doesn't. I guess because it's should be perfect. Huh. I guess the way the math works out. Dude, this is brutal without vector math. Oh my god. So sign dot cross product 3 times. I almost wonder if figuring out how to do this in a for loop. Man, this is so expensive. I am really thinking that I'm going to have to do the distance field volume option, because I do not think that there's going to be a way to get this giant thing of code running effectively. So I think what I'm going to do is I am going to just call these cross product functions each time and not worry about optimizing it to begin, because there's so many. See, that's the thing though, is like, even without doing it, it's still going to be really hard doing this with all of this math. So I guess adding up the sign. See, this is really weird because it's just calculating cross product just to add up the sign of the dot product. I don't know, I feel like this could be optimized, but hold on, let me look up. Optimize distance to triangle. There might be a better way to do this. Project point onto edge. Yeah, this is actually the exact same thing it's doing. Oh, and there's the squirrel. Alright, yeah. I'm just gonna slowly just convert this. So now we need to cross BAX and normal. Alright, yeah, I'm doing this with cross product. It's just, or with the cross product function, it's so much easier. This way I can just test the function way quicker. So I need to do dot product of this cross result with PAX, PAY and PAZ. And I actually just need to do the sign of that. Okay, now I repeat that 3 times. Except this time I do CB instead of B, BA. Do it with PB and then PC. Okay, I see the pattern here. we add that up in this sum. And we're checking if this is smaller than 2. Okay, so we actually know that if any of these, wait, smaller than 2, so this can add up to 3. Wait, hold on a minute, sign, that can be negative, right? I'm wondering if we can actually bail out of these early, like if we know that one of these is -1, then we know this won't be able to add up to 2. Like if one of these is 0, because it needs 2 of them. So if the first one's -1 and if the second one is 0 and it's, you know, I shouldn't bother about optimizing it yet at this point. Alright, and now I'll just do this simple check. If sSum smaller than 2, then we do the one thing, otherwise we do the other thing. So let's do this smaller one first. If it's not smaller than 2, then we do this dot product times dot product divided by dot product. So let's do normal PA. Am I hallucinating, or is this the exact same thing multiplied by the exact same thing? No, that is the exact same thing multiplied twice. So we can just do t equals nx, pax plus ny times pay, type out the dot product. Math.min distance dot product times dot product divided by normal x dot product times the normal dot product. Okay, that should do it for that part. So this doesn't look like there's any cross products or anything here, so this shouldn't be too bad. I need to break this down though step by step. So first of all, it does dot divided by and clamps that. Can I do this without... Hold on, when it does min here, BA, so this is a 3-dimensional. Oh, it's of the dot products. Okay, never mind. I see what it's doing. So we do these one by one. And we're going to limit these to 0 and 1. And then that's scaled by BAX subtracted from PA. Okay. I wonder if I should just use fbuff for this, or... No, just make it temporary variable. Oh, I understand what this is doing now. This actually gives us the distance to the nearest point. I think this is almost like triangulation, kind of. BAX is the direction to the triangle, or one of the possible directions, and then from this it finds the minimum closest direction. Let's see, and then this whole thing, the minimum is calculated from this. So I think I can just do math.min dot product of this. I believe that should work. I just need to step through these one by one. So much vector math. And then this is exactly the same. Okay. And done. There we go. All right. Oh, it's brutal. Oh god, that distance, the triangle function. Oh man, I almost feel like I'm gonna do a single loop for the indices. I'm not gonna write this twice, I don't think. Oh Lord. So let's see, how do I do this loop if I do the indices? It's basically the same except for when it reads in the vertex data. So yeah, I think I can do these. Indices.length or its verts. I got stuck in my assignment again. It seems like you've been doing pretty good on your assignments, though. You said you've been just finishing them. Dude, that dog is such a loud barker. The whole neighborhood hears that shit. Could you help me? I mean, if you ask the question, sure. Teacher asked you to make a math program. Math is hard. Okay, so now to do this, we read the vertices using the indices, like this. So this is actually slower. Now that I look at that, that's actually a really interesting thing. It's actually faster to not have indices when you're calculating this on the CPU. Alright, that looks good. I think that's it. I think that's our basic collider mesh distance function. I'm just thinking if there's anything else I need right here. Like, I might need a bounding box to calculate how big. Yeah, like I need some bounding radius here. And so this is going to decide whether or not the object can fit. Oh, I'm just thinking that's different than scale x. So this expects that scale XYZ actually represent the mesh size, or actually represent the collider bounds. But the issue is that sometimes the scale isn't actually the bounds. Like with the mesh collider, you actually might want to scale the mesh but have the mesh collider be constant. Huh. Variable 1, then variable 2, then variable 3. So if I enter variable 1 equals 1, variable 2 equals 3. So it just adds up whatever you enter. I'm almost thinking I need to separate this from x and z to bound radius. Like, I think I need to add a bounding radius thing, and that just makes this so much easier. Like, so much easier. Then this just becomes bounding radius. Like that. I think that's the way to do it. So that way I can set the bounding radius from the collider mesh here. I wonder if I should just have the bounding radius be a super high value to begin, so that things are always global colliders unless you know what you're doing, and optimizing with the lookup table. That actually makes sense, I think. Giving a big value to begin. Arithmetic program. Yeah, but what you're trying to do, doing 1 plus 4 plus 7 plus 10 with all the variables, You're adding up any variables that are being entered. Okay, I think I'm ready to test this. I'm just thinking, do I need the bounding radius here even? I do not. So this will support rotations but not scale. I'm actually really thinking, because one of the really nice things about having triangles here is I could actually apply scale to these. Like, I could actually multiply these by a scale value and things would still work great. That's actually a really good thing to add. That would be something that the distance field volume couldn't do. Whatever. Let's try just super simple mesh collider to begin. I'm gonna try doing physics with 24 tick rate. I just realized my gedit just bugged. Oh, never mind, it's good. 1 is the first number, 2 is 2. For the addition, 3 for the last number. Yeah, total them all. Yeah, total them all is adding them all together. So here I'm going to initialize. I think I'm just going to make a full custom collider for the terrain. I don't know, because like, I'm doing this for the first time. I've never used this part of my engine yet. I'm just thinking I could use scale XYZ. Or maybe bound XYZ would be better. Yeah, maybe calling this bound XYZ. That would actually solve my problems. So you don't have separate bounding radius and all that. You need to total them. So you create a variable called total, set it to 0, and then every time you get an input variable, you do total plus equals whatever the input is. I think I'm going to change this from scale x to bound x. Circle and box sizes are defined by bound x and y. And then I'm gonna need to go and fix up some examples if I change this, but I think this is beneficial because then the custom colliders, so then the bounds can actually match the custom colliders while not changing the scale of the object. Alright, that's the last references of that, so let's go and change it here as well. Awesome. Now I just need to remove this bounding radius part, and I need to change this back to bound x. Oh, and right here, because I did the same thing. How many program that keep adding the number? You just create a value called total. That's what the... Wait, what do you mean that keep adding the number? Like, when you run the program, it keeps the... Like, if you set a number to 5, it's going to keep that number at 5. So you just keep adding to that, and it's just going to stay at that. Like, how do you make a program that adds a number? You literally do plus equals. Like, are you asking how you do plus? Like, how you do add? Are you... What kind of tutorial are you taking that you don't know what add is? Like, what kind of tutorial is it that it's supposedly on arithmetic but doesn't teach you what the adding sign is? Alright, well, I'm not making up for your teacher. I think everything is good to go. I'm just double checking right now. Okay. So now tcollider custom data equals mesh collider custom distance equals physics collider mesh 3D distance. Okay. I'm just thinking, is there anything else I'm missing? I think the bound X and Y are going to be good. The max size. Alright, I think that's it. Let me just add enable physics, and then we'll spawn a particle. Maybe I'll spawn particles in a circle. I don't know, JavaScript to begin. Let's just do a single particle. 0, 0, 0. I'm thinking this is gonna fail. Yeah, reference error, physics collider mesh 3D not defined. I forgot to include that file. That makes sense. Return not in function. I must be stupid. Wait. Let's count these up. We've got the opening, closing. Oh, we got one too many. Should have realized. Physics collider mesh 3D is distance, it's not defined. Oh my god, I did a capital H. Okay, alright, the ball just fell straight through. Let's look at our one body. Yep, it's just falling forever. So the collider was not put in the global colliders. It was put in the map. So that's the issue, is it's actually in a lookup table when it doesn't fit. Okay, So now it should be in the global colliders. So now here's our mesh collider. Custom distance. Shape equals 2. Physics enabled. So I guess there's something broken about our distance function then. I feel like maybe I should graph out the distance function. Like I could actually just generate a 2D layer of the distance function. Yeah, so just to make sure everything works, I think I'm, like, just to make sure the function is actually plotting correctly. So I'm just thinking how I'm going to do this. I'm probably going to disable all the rendering. Generate 2D distance field layer. So we create a canvas. I don't know if I should make it a specific resolution or anything. I guess I will. just going to loop through a bunch of coordinates. I'm just thinking how far I want this to go across the world. I guess like 10 units to 10 units. And we're going to plot out the 2D distance field at a z. So that's the world x, or sorry, world y. This will be the world x. Goes -10 to +10. And then what we're going to do is we're going to sample the distance at this point from the physics 3D collider mesh. And clamp that to 255. Maybe scale it up by 10 or something. And then we're going to output this to the canvas. I forgot, I also got to flip the Y here because image Y is flipped from world Y. Alright, so that'll set the grayscale to the distance, alpha to 255, and then we're just going to add this canvas to the body so it just displays. Also set the z-index to like 5 just to make sure that it's displaying over top of stuff. And also, I mean, position equals absolute. Oh, so this is super slow sampling the distance function. I might have actually frozen it. So it looks like it's completely clear. Oh, I didn't put the image data. It's just completely black. That's not good. That is buggy. So that means that something is wrong. Let's just try outputting just 255 so it outputs all white. Just to make sure everything's working. Yep, okay, all white. Vertices, indices. What else? What could I have done? Maybe the indices is wrong. Oh my god, I'm doing the indices wrong. So these are, oof. I need to get one index per vertice. I think, hold on, wait. The index points. Oh, they need to be multiplied by elements per vertex. Ooh, indexes are going to be a lot slower in this than doing regular vertices. Well, I guess that's the way it is. No problem, Andre. I don't know what I did to help, but I'm glad I could. Okay, so this isn't going to be that bad for performance. Whatever. I'm thinking the performance is going to be horrible for this anyways. From what I saw from that, it can't even do like 1,000 samples of this a second. Okay, that returned white on its own. Interesting. That looks kind of promising. Maybe the trick is to actually scale distance down. Hold on. I'm just wondering, why does it go white right here? I guess that's the distance from the surface. So it actually looks somewhat correct now. So 256 times 256 is 65536 samples, which is a fair number. So I'm just thinking maybe if we move the Z Dude, I shit you not, my neighbor keeps vacuuming up leaves that fall on his deck. Like, we got a new neighbor, and I don't know if he understands how fall works, but I shit you not, like, fucking 5 times a day this dude is out there. New leaves fall on his deck, vacuums them up. Jesus Christ, dude. Like, holy shit. Alright, I'm going to remove this for now. See if it works again. Hopefully the particle won't just go straight through this time. Oh my god, it actually hit the surface. Except it looks like it's floating. Oh my god, it's actually kind of working. Except it just stops. I don't know if it's supposed to bounce. I think the normal is wrong. I think the custom normal I have right here. Wait, where is it? This is the wrong direction. So what if I scale these negative and flip it around? Will the ball bounce? No, that's very weird. Let's try and output the normal. Question is it even running this? I guess so. And z is -1. Hold on, I think the distance field is broken. Yeah, I think the distance field is broken. Because that should not be 1 on the z. What if I increase my epsilon? Maybe the epsilon's too small? No, it's still 1. 1 on the z. Huh. So if the distance function is correct, then this distance derivative should be correct. Which makes me think that this actually isn't working correctly. Let me move the particle a little bit over. Let me see. Okay, first of all, it seems to always float a little bit above the surface. It never seems to completely hit the surface. The z seems wrong, which that could actually be this rotate 3D afterwards. I don't think so, but no, it's not that. But this derivative should not have z. So I do think that my distance function is wrong. That definitely seems to be landing on the wrong parts. Like it doesn't actually line up with the... See, this is interesting. It's actually like the mesh, but it's just raised up by like a slight little bit. Which is really funny because this is the issue I was worried about having with the distance field volume. So if this happens without the distance field volume, I'm just going to be like, well, kind of saw it coming. What's wrong? It needs to be I plus equals. The compiler should tell you that. It should highlight that part of your code. I wonder if it's this part where I do it min. I don't think so, because it should evaluate to be the same thing. Maybe I'm missing something about how this works. Did I miss gaming time? Yes. Played like an hour of Super Meat Boy this morning. Very fun platformer. I wonder if this part's wrong. I almost feel like this is typed incorrectly. Dot normal PA times dot normal PA. There's no difference there, is there? If sign smaller than... Oh, square root. Oh my god, you have to do square root on that. Oh. Hold on. So I can just apply square root here. Oh my god, this would explain completely what is happening. Let me just check. What's a decent sized variable? Okay, 1e20 is pretty damn big. So let me see. That probably changed this as well. Nope, that's still doing basically the exact same thing. What the hell? How's it going? I'm on like the final difficult part of my game engine where I'm trying to get mesh collisions, which is like the hardest collisions to get in a game because they're insanely slow. So I'm basically trying to get this ball to fall and line up perfectly. I don't know if you can see there's like a tiny gap between the ball and the surface. Bugs the shit out of me. And this NX, NY, and Z. NY is supposed to be 1 or not. It's not supposed to be 1Z. It's returning the exact same thing every single time, which actually could be an issue with, I'm not sure, it could be an issue with the distance function. Could be a lot of things. And this right here in the corner is a visualization of the distance field across an area. But that doesn't seem to be working properly either. How's it going with you? I thought that visualizing this distance field would help. Did not help. It tells me already what I knew, that it's wrong, and I can't tell what's wrong about visualizing it, so let's just try moving our point around a little bit. So it does seem to be landing like perfectly on the mesh. Like the distance field actually does seem to be perfect. Like it hits the mesh, it gets stopped. There's just the question of why this normal ends up being always 1. It doesn't make sense. Holy shit. What was I thinking? So the custom distance function, in one part I have it return distance, and in this part I read it from fbuffer. Oh my god, I'm an idiot. I just found out what I'm doing wrong. My distance function is fine, it's my normal sampling. It's okay, just chilling before I sleep. Good stuff, dude. So here's the thing about this mesh collision. This is like crazy to me because this is something I've actually been procrastinating because of how difficult it is. But like once I get this done, it makes game development so much easier, because what it lets you do is like you've got bounding boxes, right? Where you try and like fit a box around a 3D model. And the reason you normally do that is because boxes are way faster, so in any instance where you can do that, you want to try and do that in a game. But there's so many instances where boxes can't fit the shapes that you're trying to have in a world. So you need a mesh collider, or something that can just fit any triangular mesh shape. And this just lets me do that. If I get the shape of like, I don't know, a giant dick, and you want to climb around on that dick, you can have that crazy floppy dick shape, man. Like, it's crazy. The possibilities are endless. So hold on, this is broken. So now what I'm gonna do is I'm just gonna fix this easy. Oh my god, this is good. This also makes it so much easier to code. I'd like that. Oh, dude, Gachi is fucking crazy, man. There's actually people commissioning, like, fisting VR games and shit now. Like, I don't know how I feel about it. On one hand, I feel like good shit. It doesn't hurt anybody, and people get to like express themselves. But I feel like it has the same thing as like, I can't remember what it's called. Oh my god, wait, it's not working still. Am I a moron? What am I doing? What am I doing? plus z minus plus y minus plus x minus, everything adds up. Talked about this the other day though. When you draw characters in games, actually I can show this on the Mixamo site. So this is free characters for games and things. These are like free pre-made characters and things that you can just like use for free. It's by Adobe. Adobe actually does some cool stuff. But one of the things that you just gotta notice is like, so like look at all the male things. I mean that's furry shit, but like, so it's like, it's alright, right? Like it's a soldier dude, okay? But then look at the women. So like even this is like, this one's actually pretty good. But like the majority of them, dude, look at this shit. Like so it's like, and then you get the men and it's like, you got fucking Douglas over here. Dude, look at this. So it's basically like the characteristics that we describe men by, like boss man here. The characteristics that you describe men by are like rough. Like their character is actually like, oh, this guy's a mob boss. Like his character is actually like a personality. Do you see what I mean of how bad it is to say that like these people, like this is alright because it has a sword and stuff, but like, do you see what I mean about how it's basically saying the character's personality is like all its sexuality? And then it's just fucking weird when you get into like kids and shit. But like, I don't think you really notice this shit until you start designing the characters, and then you go, hey, I'm gonna design characters that people want. What the fuck? People want the most fucked up shit? Like, Jesus Christ. Everything's good in moderation, including altered reality. What is happening? What is happening? So, I thought it was my function here. It was not the function here. It's still broken. So that's disappointing, but I mean, if I could use a male character and skimpy character, that would be a nice change. Dude, that's what I feel like the Ricardo meme at least gets. Like, and a bunch of the Gachi shit. Like, it's really weird, but like, I feel like the equivalent of those female characters with giant, basically, sexual organs expanded massively. The equivalent of that, I feel like, for men is like the fucking Brazilian porn stars where you got like giant pecs and shoulders going out. Based on my code, I got 1, 4, 7, 10. How do I total them? You do plus equals. You do plus. Total is adding. So do I have, am I an idiot? What am I doing here? Return math square root d. Custom distance. I don't know, maybe just output base distance. I'm actually wondering if there's something about this sampling that's broken for the triangular meshes. I don't know how this would break for it, but it possibly could, I guess. It's always the big and buff guys too, not a lot of variation. Yeah, I don't know. You get like some with a gut as well. Then you get like Conan Exiles where people literally got dicks. Conan Exiles, I think, is probably a good example of just doing both men and women. Alright, let's see what this outputs. Base distance 0.38. Okay, that's actually not correct. Oh, I'm an idiot. I'm an idiot. I changed the bounds. This is supposed to be bound x. Wait. What do I have radius? Why do I have radius here? Oh, wait, I'm an idiot, because it's a character. Derp. That still doesn't answer. Why is it stopping 3 units above? Probably because that's the last x and y. Whereas here, HObject.normal xyz, it's using the last x, y, and z. I think that's correct. I don't know, what else could be going wrong here? The fuck, I did it? Good job! Yeah, I wonder, distance derivative might just be broken for this, but I don't see how that would be the case. So this is my giant function of calculating the distance. As far as I'm aware, this is correct, but according to the normal sampling, it's not correct because it should have a derivative at any of these points that I sample, like an actual distance field. Unless there's something about the z that is completely broken, that would make complete sense actually. Okay, so it seems to me that z has very little effect on all this. So this should make it white because it's so far away. And it doesn't really make it white, which makes me think it's not using the z for something there. I don't know. I'm just going through all the z components here and making sure I didn't miss any of them. I don't think so, though. I was very meticulous when I went through these. I mean, the cross product could be wrong. I don't think so, because it is pretty standard. Maybe I'll just try it with the custom normal function and see if I can get that to work. So this custom normal just outputs the normal instead. I could actually have this double as the normal, I think. I don't know, I'm already calculating the normal here, so I feel like just doing like fbuff0 equals nx and y and z is worth doing. Then I'd have to do this manually. Yeah, both of these are so unoptimized. I think I'm going to end up using a distance field volume. I'm really interested though why this is happening. Maybe I'll just sample I think I'm just going to sample normal positions around the collider. Wait. I think I can do this just from the console. Just sample random normal positions. P collider normal. And x equals 0. So it's giving the exact same normal. So this is really interesting. It's the distance actually seems to be working 100% perfectly. So there's a slight increase on the x. Slight increase on the y. Slight decrease on the z. Decrease on the y. So this is really weird. According to this, it should be giving the distance, or actually it actually seems like the normal calculation is just straight up wrong. Hold on. So this is relative to the object. This one's relative to the object too. This is relative to the object. Unless there's something I'm missing. Maybe I need to do 2 samples? I don't know. I can just change to this formatting to make it better. So this is taking all of the derivative samples from a base distance, and this will be sampling on like crossbars. So each axis actually has completely different samples, which normally fixes any issues. And normally there aren't any issues as long as your distance field is precise, so that's the other thing. This should be a perfectly accurate mesh distance field because it's using the triangle, the actual triangle distance function. We'll see. Alright, now NZ is 1. Now base distance is 0. Alright, so it looks like it's still reporting. So this is so weird because at least when you go over to the X, the normal should start pointing back towards the center of the X, and it's still staying as Z. So I'm thinking there's something I'm calling here that's setting fbuff. Or when it writes this out, I actually wonder if when it writes this out to the console, it's not giving the correct values. No. It should be. So then I can also sample custom distance like this. .8, 2.81. I guess I'll calculate these manually and see what I get. Zero. Very interesting. What if I make it negative? Exactly the same value. What if it's offset a little bit? Okay, it's a slightly different value on the x, which is what we saw. Is your Discord for programmers only? No, just a bunch of people. Just doesn't seem to really be limited to anything. Alright, I want to see, the derivative should increase as you get to like 1,000 units out from the mesh. But it stays 1e negative 8. I guess that's because the amount that it samples. Okay, let's try this with the y now. So the y is also 1e negative 8. So what I'm thinking I'm going to see here is that the z is going to have some insanely big value, and that's what's going to end up normalizing to 1z, because the z is just so insanely big. Alright, so that actually matches up. There's more derivative on the x than the y when it's over far on the x. So finally, let's try... Did I do 1e8 somewhere? That would be a that would be an actual mistake. 1e8? No, those are all 1e negative 8s, I believe. Yeah, this doesn't add up. There's actually more derivative on the x here. So hold on, let me actually fully calculate this. Calculate this by hand and then compare the result from that normal function. Politics channel is very interesting. Didn't realize that boats are really bad for the environment. Yeah, I think it's like the same thing as businesses, is that people go bankrupt or whatever and they can't afford to maintain boats. So then the people that you even fine for leaving the boats to damage the environment end up like you can't even like blame anyone because the people who have already caused the damage have no fucking money anymore. Or as we are seeing with the US president currently, you can have hundreds of millions of dollars and claim that you don't have tons of money as long as you just give it all to your family. Yeah, I think the big thing from that was that Trump has like, I think it's like $400 million in loans that are coming due in the next like 2 years, which is huge. dx dy. Oh my god, it's correct! Dude, I just calculated it by hand and it's correct. Hold on a minute. Wait. Wait. What? Excuse me? Hold on a second. F0, fbuff1, fbuff2. fbuff2. So wait. Look at this shit. So derivative sample, 1,000 on the x. Let me just make sure I have all this right. Yeah, it's 1,000 on the x every time. And then if I actually do this, 1,000 on the x, normal is 1e negative 9. Whereas the normal here is actually the correct. So dude, there is something going wrong in my normal function right here. tcollider.x, the xyz is 0. So this should have absolutely no effect. This should have absolutely no effect. I think. Let me try. Yeah, so that didn't do anything. So then let's calculate it manually again, and we get the correct result. So this is so weird. Hold on a minute. So first of all, I need to sample this because after rotating, the x, y, and z are in fbuff 1, 2, and 0, 1, and 2. X, Y, Z plus. Wait, what? I'm so confused. Maybe I'll just rewrite this all. But I'm super curious because I must have written something wrong here. I wonder if it's setting cn to custom distance here. It's not actually calling Custom distance? I'm not setting fbuff anymore here, am I? Oh my god. I'm an idiot. This uses fbuffer. I expected that fbuffer isn't used across these custom distance functions. Of course. Of course. I need to create temporary variables to hold this. This uses fbuff 012. I guess I could assume they don't use fbuff 3, but that might not be a good idea. I'm very happy though. I just found out what was wrong. Now I just have to decide how I want to rewrite this so that it will work. So first of all, I gotta copy these over to buffer them. Now that I know everything works, I can use this base distance. And then we're going to do each distance one by one. So X, Y, Z. And so what should happen when this works is that in our little example here with the ball that falls that you can't see currently because I have it disabled, the ball right now just falls and stops. So what should happen when this works is that the ball should actually bounce off of, like, I don't know how to describe it. Like, the ball's supposed to bounce when it hits the ground. It's not supposed to just stop, go like thump. So I've got a specific thing I'm looking for. Yeah, there's no rolling, so it'll actually slide. Or the appearance of sliding is actually just bouncing a super tiny bit. Alright, here we go. Oh, look at it. It works. I'm just watching for bugs. So far, it looks like everything's working. So it's got one bounce, which actually means that this should just keep bouncing forever. Alright, this is really good, because this now means I can actually do the real part of this. And that is benchmarking how goddamn slow this mesh collision is. Because mesh collision is like, okay, so there's 800 triangles, right, in this terrain. every time this ball has to move a tiny bit, it's doing a for loop through 800 triangles, and it's running this code for every single triangle, which is absolutely brutal in JavaScript. Like, this is so slow compared to all the other stuff I do in the engine. I can't even like put it into words. But I'm just so happy it's just working. So this is a quick and dirty solution, but it actually does have a use. There are a bunch of times where you might just want a small like 20 or 30 triangle mesh. Also, I can actually apply mesh scaling to this, which you can't do for distance field volumes and other ways of doing the mesh distance fields. So I kind of do like this method just for that approach. Also, one thing to just say, a lot of physics engines like PhysX actually have this issue where objects can go through mesh colliders at points. Like, you can just clip through corners in places. So the one thing about this technique is there should be no clipping ever. It should never fall through the ground. Alright, so let's take out this debugging. Alright, now we're actually going to make this slow. So you run this, you'll see, oh, this is going to bounce too high. This is actually just going to go out of the map, I think, at one point. It's just going to bounce at the right angle and just go flying out the map. But yeah, you'll see here 24. This is the tick rate of the physics. 24 is very low for physics right now, and this is part of my issue with the mesh collider, is I'm worried that when I have the mesh collider, won't be able to do like 100 iterations because it'll be too slow. So we're actually going to ramp up the iterations, and it should give us a linear measurement of how many iterations with the mesh collider we can get. I'm also just making sure the collisions actually line up. Yeah, it's looking really good. It's looking really nice. I'm going to increase the gravity because it falls really slow. You need shadow. Yeah, there's no real lighting in this yet. Here we go. So this is actually moving at a decent speed now. So, tick rate 24, let's try turning up to 100. Let's see if it can hit 100. I think it should be able to. Yeah, so it's hitting 100, no problem. Not bad. The other thing I'm thinking about is I actually can do a basic optimization with this system where this is actually kind of fun to just watch it bounce around. I could actually do a system where it doesn't check all of these vertices. If it's outside the bounding box range, it just returns the bounding box distance, and that could actually work as a sort of optimization. But yeah, so far it's working amazing. Actually working better than I thought. So I think 1,000, I'm going to up the rate to 1,000 now. I don't think it's going to be able to get 1,000 ticks per second, but we'll see. Okay, we have 1,000 ticks per second. This is probably the smoothest physics you'll ever see. Let's go 2,000. So I'm gonna be completely honest here. If I can get, let's just go straight up to 10,000. If I can get 10,000 times 800 per frame, that's insane. Yeah, so if I can get 8 million of these mesh collider samples per second, that, oh my god, that is actually, okay, here we go, 10,000. It has frozen. Let's see if we can look in the console. Oh my god, so it's actually hitting 10,000, but it just freezes and locks up the rendering. So I think we should be able to get 4,000. Should be able to get 4,000, I believe. Yeah, so there's 4,000 with a tiny bit of stutter. I'm going to be honest, I thought I was going to need to optimize these mesh colliders to actually get them functioning. This is crazy. Mesh colliders are a go! Yeah, I'm just thinking, this is actually fast enough for ray tracing now, even with this, but let's, I'm definitely determined to still optimize that. So I think that's what we will be dedicated to today, is trying to optimize the mesh collider. I'm just thinking, I'm going to build this into an actual 3D example. I also want to test 3D audio with just the JavaScript audio element. I want to try just using the panning to change the panning as you go around the 3D world. I think that'll work, even though it's not completely real-time audio. I believe it'll still give a pretty good experience. I'm going to turn it into like an actual little 3D example scene. And then I think the next thing I'm going to go towards is an actual visual editor, because that is so helpful. And then post-processing and lighting. Yeah, I'm just thinking I might try, I can't decide if I want to go and do the first person example first, or if I want to try to optimize this with like a BVH. I think I'm going to try to do some access aligned bounding box and like BVH optimization on this. Gonna head out, Ethan. Have a good one. To Andre. See you around, Boss GI. Yeah, so if I optimize this in a BVH, it would basically be splitting the triangles into a bunch of smaller submeshes that are contained in boxes that I can very quickly search through so that the collision gets way faster. Or, so this is the other thing, like this is so nice because this actually gives perfect collisions. Like it's actually 100% one-to-one with the triangles, but the issue with the optimization approach is like the distance field volume. Oh, what is this? It just got stuck. Oh, weird. It's actually stuck in a corner. Oh my god, it's stuck and the velocity's just building up because it's just bouncing back and forth. I think this is eventually going to fly. I'm actually really curious, is this a bug in the distance field where it just got stuck? Yep. So that's... there goes the ball. It's literally like those cartoons where it's like... blink of a star in the distance, like Team Rocket signing off again. Oh my god. So yeah, I was kind of aware bugs like that do exist. If you get the body stuck between two corners, and the way the normal works is it never returns the exact spot it was in. The normal was returning 0 or something, so it never... Hold on, I think I can actually code this so that it always returns something. I think that's the solution. I'm actually going to test this again. I want to leave it running, try and solve that. I believe if I just do this, that should fix it, maybe? I'm actually super curious. Let's just try doing that. So if I leave this running again, it is deterministic, so it should get to the exact same spot it was in the last run. So I'm gonna go get breakfast now. I'll be right back. There we go. Okay. Okay. So we can see our sphere got stuck again. How much is the velocity built up? Yeah, so the velocity y is built up to 100. So if we just flip this up to 10, oh wait, never mind. Oh, it just shot out into oblivion, and it just lagged super badly because it did. So this obviously didn't fix that issue. I'm wondering if this affects it, of the direction of the normal. I'm thinking there's actually no way around this. It's just like, if you like, you just get these situations where like the normals are just the completely opposing direction, so like the sphere or the body just gets completely stuck between it. That actually happens in video games too. You can like get stuck. I almost feel like this is like, you can just design the world so this doesn't happen. Just design the world forehead. So that's the thing. If you want to do procedural generation, it's actually something you need to think about. I'm also thinking doing an actual normal function for this should do it. Kind of bugs me though that this normal function is going to need to calculate all of this same stuff for distance and then just output the normal instead. That seems like kind of a waste. I'm thinking there's some way I can skip the actual exact distance, but that's the thing, you need the minimum distance. So unless I like, so that's actually the funny thing is, no, there's no way you can know that. Like, I can't think of any way I could actually save what mesh collider it hits. I wonder if what I changed is actually going to change how it moves each time, or if it's still going to get stuck in this hole, because I actually think it did change how it moved here. But yeah, until I do get the custom normal function, this is just fine. I'm also thinking I'm going to optimize this before I do the custom normal. Yeah, so there it goes, getting stuck again. So yeah, it's something about that normal, and it's not even this incorrect 0 normal. It's just, yeah, just the way it is. I gotta fix this so it always outputs something, even if it's 0. I think that's actually an issue with physics. I'm gonna need to fix up physics 2D as well here after doing physics 3D, because there's some stuff that I figured out is broken as well in 2D. Alright, let's just try and do a little normal function. Let's copy this. Alright, and now we can check if sum is smaller than our minimum distance. Then we now set the normal to this normalized normal. And we set the distance to sum. And I guess this will still return the distance, maybe not. So now there we go. Now we should be able to put this in tcollider.custom normal 3D normal. So now it has the correct normal. I'm going to debug this just to make sure it's right. Okay, that's completely broken. NZ equals 10. Jesus Christ. Oh, because this reuses fbuff. Oh, I see. I see. So I actually need to store the output XYZ in buffers or their own values. And then when we output it, we go fbuff0, fbuff1, fbuff2. Alright, I think this will work now. Plus 1. Yeah, that's all looking good. That's looking really nice. It's basically giving the same result, but a little bit different, because the normals are... Ooh, that was weird. Did like a weird side angle there. I wonder if it's because it hit the edge. Seems good though. I think I just deleted my assignment by accident. Tell me you have a recycling bin. You should always have backups. Alright, I didn't actually go get lunch before because I saw that the simulation failed. It got stuck again. Hopefully it won't get stuck this time. I think it should be good. Because it should have the proper... I would actually expect that it might go out of the map. Anyways, I talk about this on stream a lot, but I make like 2 or 3 backups for nearly everything I do. So much so that I sometimes accidentally flip out my backups with the version I'm using and go back to an older version by accident and then go, oh, I'm an idiot. I just depatched my program. Okay, this is looking really nice. I'll be right back. Oh, what happened? I missed it. It fell. I knew it was gonna fall. I knew it was gonna fall eventually. So I just need to lower the height that the ball drops from and it won't fall out of the map. Let's see, will this work? Maybe make it a bit higher. It's kind of hard to use VS. I should make another project for every C file because I can't use the same include on every project. Yeah. Each person kind of has their own way of doing that. Alright, I just heard this game. Never heard of it before. I'm really curious. Hold on. Let me see if I can bring it up on Steam. It's actually like... This game just... I don't know how I haven't heard about this game. It just appeared on the Twitch directory. Genshin Impact. How the fuck does it have so many people playing? And how haven't I heard about this game if it has so much? Oh, it's available on PlayStation, so that's something. Not a lot of MMORPGs on PlayStation, I don't think. I'm just trying to find like a Steam trailer or something. It's on Switch. Yeah, it's on like everything. Surprisingly lack of info. It just seems like people surging to some hype.
Hey, there's something strange over there. Come on, let's take a look.
Okay, this could have huge potential, but it could also just be a fucking money grab. Okay, what does actual gameplay look like?
Speak my name.
This is supposedly a gameplay trailer. There's no way this is what... There's no way this is what the gameplay looks like. That is third-person camera shots and like... Genshin Impact gameplay. Oh, so you have like 4 different characters that you switch between? Interesting. Okay, I think this is gonna have no end game and have serious issues in terms of actual design. Yeah, it seems to me that they're advertising it as more of a super pretty, like it seems like the type of game that's really gonna get you to buy super pretty looking MTX and really beautiful looking art things, but the gameplay is probably gonna fall short in my opinion. I'd be really interested to see how many people are still streaming this and playing it in a week. Hold on, I want to try to I tried to jump into some streams earlier and just see what people were doing. But it looks like people are just walking around. So, looks like Zelda. Yeah, it does look like Zelda. There's tons of Breath of the Wild type clones coming out these days. Okay. It's actually got pretty good 3D movement mechanics and stuff. Like you can climb up edges. Interesting. I'm trying to find some gameplay of people actually doing like fighting or something. I still haven't seen anybody do combat in the game. Just watching your face. Yeah, like I don't want to show other people's streams on my stream, but like okay, here's a person fighting. Okay, cool. It's like your classic third person hack and slash. It looks like you only have one or two skills, but you have 4 characters. I'd be really interested to see like a review of it from like someone who actually knows what they're talking about. Hold on, let me see. Let's see if the MMORPGs Reddit has. Why is no one talking about Genshin Impact? It's not an MMORPG, it's lobby based. Very interesting. Max 3 players. It's a co-op. What the fuck, dude? How did this get advertised to me as an MMORPG? Why the fuck are people calling this an MMO? Co-op is heavily restricted to the point of the game being single player. Story and quests are unavailable in co-op. Players cannot open chests in co-op. Merchant NPCs are unusable in co-op. Generally believe the game could provide a lot of entertainment for friends. Wow, it's really interesting that that's the type of game that they're like filling up with microtransactions. I would think if it's mostly co-op, like I think big open world MMORPG is what people really want to spend money on cosmetics for, because like it's the whole thing of, oh, there's this big world with like thousands of other people. If I spend $100 on this really expensive cool looking thing, people will think I'm rich or whatever. Like, you know what I mean? It's like the status symbol comes from all the other people seeing, like in Path of Exile, people have this theory that the only reason why there's even towns in the game where you can see other players is just so that other players can show off their microtransactions and brag about them. So I feel like Genshin Impact kind of fails that. Because, like, if it's co-op and you don't actually have an MMO, I don't know how they're advertising the MTX to everyone then. Alright, hold on, I'll be right back. Oh, it got stuck. Why one? Ooh, why is it stuck? Circle of Satan in every RPG game? It's true. Yeah, it is stuck. So velocity x is 1. I think it's at like the absolute inverse normal. Like the normal is actually inverted from the velocity. So if we just flip around the velocity, yeah, it just goes flying. I wonder if I should do something to calculate if it gets stuck. Because technically this actually isn't really an issue. Like that's almost like an expected behavior of something that should happen if it gets stuck between two things. I'm just wondering in the actual physics step, what would that even look like? Is I guess you would calculate that the normal just keeps, I don't know, I think it's something with the dot product going past 2 or something. Maybe I think I need to do max 0 somewhere here or something. Yeah, what if... So this flips it negative, but I don't think it should ever actually be negative. I'm just making sure. It almost looks like stuff is off now. Like it's not bouncing correctly. No, it is. Okay. So now that I've made that little change, I think I'm going to leave it. And we're going to see if it gets stuck again. Because, yeah, I don't know. If this is something I can fix, I'd definitely like to do that. I don't know, I'm thinking... I'm still thinking how I would optimize this. Like, I've got the bounding box idea, like... I don't know, I feel like I should be talking about this stuff on stream of how I'm visualizing it and all that, but it's really gonna slow it down. I'm almost thinking of putting on like a Kurzgast or something while we wait for this, so it's not just like BRB. I don't know. I think we might do some chess puzzles. Because they are so fun. And I can just let this run in the background while I do puzzles. When you're gonna put shadow? Lighting later today. I think I'm gonna do lighting later today. I'm not sure. I kind of want to do a post-processing system before that, like do bloom and that stuff, in case I want to do some kind of deferred lighting, because that is possible in WebGL. the thing. I kind of do want to see when it gets stuck, but at the same time, it's no big deal. Alright, what's the best move here? Well, I'm already stumped. I think it's something with the king right here. What did that just open? Oh, okay, we get the king from that. I'm really determined to not do view solution on these. Oh, it got stuck again. Yeah, so I don't think this is any actual issue with the normal or the physics calculation or any of that stuff. This is just a side effect. So this is the movement versus the normal. What if I just do max 0 here instead of right here? So this should do the same thing. This seems like a hard one. Wow, yeah, that was like really off to the side. So then what do we do from here? Okay. Some of these I still don't really figure out at all. Oh, this is bugged. Or at least that looked bugged. Yeah, there's something definitely off when I changed that. So I think the way I changed the code, the bouncing doesn't work properly now. At certain points when it's like not aligned to the surface. It seems to kind of roll along more than bounce. I'm not sure though, that might be correct. Let's see if it still gets stuck at that spot. If so, then it's pretty much the same. Wait, what? I didn't think I beat this one. I think that just bugged or something. Yeah, this is interesting. It's almost like sliding around. It's definitely not doing the same bouncing. It's kind of like sliding. Huh. Yeah, I don't think there's a fix for what I was trying to do. Maybe? I'm just thinking. What's happening? Like, yeah, like if the two surfaces are opposing the direction that this tries to go and it just gets stuck bouncing between the two surfaces, like that's what's supposed to happen. It's more like an issue with level design if it does that. Wait, what? Oh, that puts both the king and the queen in check, and then you can get the queen. Oh my god, and it still got stuck. It still got stuck eventually. Wow. So, yeah, I guess that's just a fact, is that so this is the thing, the object isn't actually stuck. A lot of game devs might actually think and see that, or even fuck gamers, because like in a bunch of games you can go and like get yourself in a corner in a game and actually get stuck there. Like if the devs don't program, or if the devs don't design the level correctly, there's literally places you can go in and get stuck and can't move from. What's interesting from this is it's not like you actually are stuck and that you can't move at all. It's just that the ball has a fixed direction that it bounces, and the direction that it tries to bounce every time, it will run into a wall, and then it will try and bounce again and it will run into a wall that's like super close to it. It's kind of an interesting concept. I don't know if there's any fix for that, but I don't know. Let's do some chess for a bit while I try to think about how to optimize this. Oh yeah, Google gave me tons of suggestions already. There's octrees, there's bounding volume hierarchies, there's spatial partitioning, there's distance field volumes. I'm leaning towards distance field volumes because of how optimized they are, but they take up a lot of RAM and they aren't accurate. So that's kind of why I'm also leaning towards the bounding volume hierarchy. Make the ball smaller. Oh, it gets so small you can barely see it. Can you see it? Yeah, it's like impossible to see like that. What is it doing here? Okay. I didn't I did not think that was gonna happen, but okay. So I figured out one pattern in this so far. The best moves are normally the ones where you pin two pieces at once. If there are ones where you can pin more than one piece, that is probability wise most of the time the best move. Huh, that was it. Hold on, my cat just meowed and wants in. I'll be right back. That was really stupid of me. Like, really stupid. Nice. I got all of those right. Even if it was just a rating 1000. Oh yeah. I still have English and math assignments. Good luck. You know, Andre, you've said your teacher is stupid. I don't think you've been around when we've had the education system discussion here on the channel. So, your thing of your teacher sucking actually lines up with what I've talked about a lot. I think the current academic system and education systems in a lot of countries is like so goddamn bad, even if you just compare it to like random corners of the internet. So, yeah. I can't tell if my cat wants something or it's just like, hold on, I'll see. Alright, I'm right here. I'm just patting my cat. He gives us stuff that we haven't learned, so yeah, I don't know. It's a huge complex system. The huge issue is, in my opinion, the education system is like the one system that it's just supposed to cater to stupid people. I know that's like a really that sounds really bad. But like, so here's the thing, a bunch of other places in society, you'll basically hear people go and say, it's okay that this is predatory towards people. It's okay like that loan sharks exist and all that because like people should know better. The whole issue is when you have like bad teachers and shit, the kids literally can't fucking know better. Or like people who are learning programming have no idea. It's like the one system where like you're actually supposed to guarantee that people know what they're doing and stuff here, but like it's the whole Dunning-Kruger effect. Like how can the bureaucracy or like the school districts manage what teachers are doing things properly unless like the school people at the school districts themselves know like what's happening in programming and all that. So I almost feel like it's actually like incompatible with like school current education systems and like the internet where people can kind of form their own reputation circles is almost like better. Alright, we're going to go back to programming after I eat lunch. Hold on a minute. I just noticed something. This code is huge. System, graphics, vec3, scene 3D, procedural mesh, procedural primitives, physics 3D, physics collider mesh. Okay, never mind. I understand why it's big. I don't know what best move is from here. Oh, it's actually just going for the rook. Okay, we're just trading, I see. Wow, that was rating 2000. Is that a vape? Yep. What do I do here? Hold on a second, I'll be right back. That's a... So wait, what would happen from here? Ah, it doesn't let you see. There, that would... I don't think it would do anything to guard. I would progress my pawns, and I think I would end up beating those. Oh, nice, because we already had it put in a corner. Oh, that's a win. Okay. Hold on, I'm gonna go get lunch. I think we're gonna watch Kurzga. Alright, it's time for Kurzgast.
In nearly every corner of the earth, ants wage war against each other. Their weapons are what nature gave them. Some have strong armor, deadly stingers, or sharp mandibles. And then there's this tiny and not very impressive ant, but it rules the biggest empire any ant has ever built. A colony spanning continents and fighting wars that leave millions of casualties. Let's take a look at this unlikely warrioress, Linipithema humanae, the Argentine ant. This story begins in the floodplains around the Paraná River in South America. It's a crowded ant megalopolis where dozens of ant species fight for dominance, including fire ants, army ants, and the rather unimpressive Argentine ant. It measures only 2 to 3 millimeters in length, and with its small mandibles, it's surprising that it survived among its buff competitors. Their homes are equally unremarkable. Their colonies range from fairly small to very large and can be found anywhere, under logs, in loose leaf litter, or the former colonies of other ants. Here, Argentine ants prepare their most effective weapon against their competitors' bodies. Most ant species have only one queen to produce ants, while Argentine ants went all in on numbers. For every 120 workers, there's one queen, laying up to 60 eggs a day. So their colonies grow fast and have millions or billions of individuals. Teams of queens and workers frequently branch out and found
Goddamn
new colonies.
Zergs!
But this strategy has a downside. As colonies grow and produce a lot of offspring, mutations occur and new colonies adapt to new environments. Their DNA slowly changes from generation to generation and differences accumulate. So after a while, the ants that left the colony will become more like distant cousins and start to compete with their mother colony. In their native South American range, this is how Argentine ants behave. Within their colonies, they are very cooperative and well organized, but they fight vicious wars against other Argentine ant colonies and other ant species. With equally strong opponents on every side, the Argentine ant became extremely aggressive, fighting for every inch of ground. But it could never dominate its neighbors, until humans showed up. We did what humans do and transported things around the world by ship. On one of them, a few Argentine ant queens hitched a ride as stowaways from South America to Madeira and New Orleans. The Argentine ants suddenly found themselves in a strange world. Instead of being surrounded by deadly enemies, they found only victims. Nobody could fight them effectively. Because only a few Argentine ant queens were introduced to the outside world, the resulting colonies had very low genetic diversity. On top of that, the introduced Argentine ants kill up to 90% of their queens every year. Fewer queens, less genetic variation. So, as these colonies spread across the landscape, ants that left the colony were no longer considered distant cousins. As a result, the new colonies form not opposing, but cooperating parties called supercolonies. This is a very uncommon strategy in the ant kingdom. Only a few of the 16,000 ant species have evolved supercolonies. A supercolony was established on the west coast of the USA and became a base for the tiny ant's global conquest. Today, the Argentine ant inhabits the Mediterranean zones of 6 continents and many islands. This one supercolony was especially successful, establishing sister locations in California, Europe, Japan, New Zealand and Australia, forming one massive intercontinental megacolony of Argentine ants. This makes them the largest society on Earth, more numerous than even the human one. But their success has changed the ecosystems they invaded. California is a perfect example of this. In their greed for more territory, the invading Argentine ants have overrun and replaced 90% of the native ant species, including several species of Californian carpenter ants. Although carpenter ant workers are giants, their colonies have only between 3,000 and 6,000 individuals and stand no chance against an expanding supercolony of billions of Argentine ants. Argentine ant workers attack by wiping toxic chemicals on their victims, which irritates the enemy and marks them as a target for other Argentine ants. When they attack, the Argentine ants wash over their victims, clinging onto their opponents in groups and pulling apart their limbs. It doesn't matter how many of them die, there are always more. Once the colony is overrun and exterminated, the Argentine ants feed on their victims' brood and take over their home and territory. The Argentine ants' numbers allow them to hunt down and devour such an excessive mass of different insects that over time, some species disappear from the ants' territory completely. Argentine ants don't care about working with the local flora and fauna, they consume them and move on. And if their next stop happens to be human property, they will rudely make themselves at home there too. They forage in dumpsters, bowls of pet food, and sneak into kitchens to claim leftovers. Not just our homes, our gardens and fields are also impacted by Argentine ants since they tend to hordes of aphids as their cattle. The aphids feed from plants and produce a sweet honeydew which they trade with the ants for protection. Since the ants have no major enemy to fear in their new homes, the aphids thrive and ultimately kill the plants they live on. So, on top of being a major disruption for the ecosystems they invade, they are also a huge pest for agriculture. But the rule of the Argentine ant is being challenged. Parts of the supercolonies have broken off and become their own empires. A merciless civil war has broken out. For example, the Lake Hodges supercolony has been fighting against the very large colony for years in San Diego County. A massive war is going on over a dynamic front line stretching over kilometers. An estimated 30 million ants die here each year. On other fronts, an old acquaintance from the Paraná River has risen from the shadows. Red imported fire ants which were accidentally introduced from their old home to the coast of Alabama. Not only are the red fire ants fierce fighters and more than able to deal with the Argentine ant, they are also able to form supercolonies themselves. Now the old wars from their distant home have been taken to a foreign battleground. In the southeastern US, the supercolonies clashed fiercely. The Argentine ants found themselves outgunned by the fire ants. The fire ants' major workers are more than twice the size of the Argentine ants and wield venom-injecting stingers. Even though the Argentine ants fought fiercely, the fire ants were too much for them. After countless lost battles, the red imported fire ant exterminated the Argentine ants' supercolony from much of the southeastern US. This is one territory lost, but the Argentine ants will fight on. This amazing network of cooperating supercolonies is the biggest success in their history. And they'll not give it up because of a small defeat. They will stand their ground against any enemy that might arise, no matter if it's on the Paraná River or on one of the large battlefields across the world. These videos were developed with the support
Welp, that's terrifying. Okay. Alright, I'm done lunch. I've been thinking while watching the video and just playing those chess puzzles and chilling. I figured out So to optimize this with BVH, with a bounding volume hierarchy, I'm gonna want to visualize the cubes and the bounding boxes. I should give credit to IQ here. Here we go. I need to visualize the bounding boxes that'll be used in the bounding volume hierarchy, and that actually made me think of this debug draw system. So Unity actually has something like this, and I put it in my old engine inspired by I put it in my old engine, Strand Engine. I got inspired by Unity. It basically just lets you do stuff like debug dot draw line and draw like a line anywhere in your code. So it's like, I don't know if I want to call it stateless or like, or copy and paste. Well, I mean, I don't know how they did theirs, but very similar. So I'm going to create that because I need a way to draw lines of where the bounding boxes are, and this is just so nice to have for debugging at times. Why don't you use Unity? It's really bloated for a bunch of the stuff I want to do, and there's a bunch of stuff that you can't do, like, so this is the weird thing. If you use Unity and then like make your own physics engine, shit is just like weird. Like, it's like their physics engine is like built into the engine. And I mean, like, I do use Unity when I need to use Unity, but at the same time, there's so much shit. Like, dealing with, I think any developer who like manages a game right now made in Unity probably despises Unity updates, or they just keep their game on a fixed version of Unity, because just the whole thing, I think one thing that just fucks, hopefully this is going to slow down, but the engine has been changing so much over the past 5 years that you learn something 1 year in the engine and like it's changed in the next 2 years. So it's just really a horrible system where like your games actually don't last, if that makes sense. Like, the nice thing about an engine is you like have your game in a fixed system and it just works on all the other platforms. But the issue is you can't apply updates to it because the engine is like above your game. Like, this is the nice thing. Like, if you make an engine just for your game, it's actually amazing because like your game evolves with your engine and your engine evolves with your game. I'm gonna need a way to draw from the main camera perspective to the main camera. I guess I can just do debug draw camera, and this will just like and you just set it to whatever camera you're drawing with. So then the other thing is, can I do rendering without shaders in WebGL? I think you need shaders, don't you? Without shaders. Because I just need colored lines, and I think I'm gonna need yeah. Yeah, I'm gonna need a shader for this. Okay. So I'm gonna need a function that's like initialize debug drawing. So this is going to be like the camera it binds to when it does the debug drawing. What do I need to initialize here? I need a shader, debug draw shader. I guess I'll just have the shader in fixed code, because this will actually be nice. This is the whole thing, is you can just have this included and just draw debug shapes. The difficult part, I actually might need 2D and 3D debug drawing, because they're actually different. So wait a minute, let's do debug draw 2D. First of all, because that's simpler. And we're just going to have a uniform for the color. It really sucks writing shaders like this, but what do you do, you know? Thanks for stream. If I'm back maybe in an hour. Alright, hope you have a good day. The other thing is that I am going to need new lines at certain points for this to work properly, but this should be fine so far. Oh yeah, and I need attribute back to UV. Oh wait, no I don't. I just need color. This is the simplest thing ever. Attribute vec3v position, I think. Wait. Let me look at my 2D shader. Yeah, vec3v position. Okay. I am going to need this local to world. I am going to actually embed the local to world in these functions in this, so that way it's going to be really easy then. It'll just do all the camera transformations in shader. Actually, do I want to do that? Yeah, let's just try to do it like that to begin. So I'm actually thinking I should have a function in the scene 2D and scene 3D that just lets you bind the uniforms for the camera. So if you're doing rendering, man. I don't know about that. So there's all this stuff like CamX that you need to calculate and have access to. And I would have to do all of this in each debug draw call, which I mean isn't horrible, but it's really not good either. Yeah, I guess I'm just going to calculate this. I think I might not do extrapolation, just to make it much simpler. So then there's the other thing. I could just do screen to world. Yeah, you know what? Okay, never mind. I can either do all that, or I can just do screen to world with the lines, and that's so much easier. So yeah, never mind. just do, I'm actually still not completely sure about this either. I guess just output. Maybe I'll actually do vec4, because I'll have the homogeneous W coordinate. Perspective divide. No, actually that won't matter. Wait, this is 2D. And this is 2D, it won't matter. Alright, if this compiles, that's going to be really cool. I feel like it's not going to compile. And I also need a mesh. And this is going to be our buffer for setting up the lines and everything. I actually think I might use fbuffer for it, but we'll see. Just gonna have position and vertex color. Actually, not even vertex color, because that's gonna be passed in with the uniform. I'm just looking at this. I think that's everything I need to begin. Oh yeah, so hold on. There's some fixes from Physics 3D that I want to go through and do to Physics 2D. Specifically with this normal function. I just need to remove the Z. And that's it. Okay. Actually, wait, let me just make sure. I didn't mess up anything anywhere else. Nope. So now let's try adding initialize debug draw to our code. Let's see if this throws any errors when it initializes. And maybe I should have done debug draw 3D to begin, but actually, hold on. 2D should work as well. Yeah, 2D should work. If I'm thinking about this correctly. So let's go up to our initial. Oh, I do setup. I want to keep it consistent. Okay, it initialized that with no issues. So presumably our shader there is good. Okay, let's just try drawing. Let me see, yet no errors. Man, I'm so happy to just have basic mesh collision working. Like, this just makes stuff so much easier now. If I just have any terrain, I can just, boom, just throw a mesh collider on it. And we got terrain. It's great. Alright, I think to begin, I think I'm going to do line, debug draw 2D line, or maybe I'll do box. No, I think line is the basis. So maybe I should actually do draw lines, where it takes lines and rasterizes them, and then I can build the boxes and other things out of lines. Huh. There's also the whole thing of Z position, where should I draw it with Z depth testing or not? I'm not sure. I guess I could add an option for that. Well, I guess for 2D you can just provide a Z. I almost feel like I should do it with no depth testing just to keep it simple. Yeah, whatever. Depth testing is more accurate. So what I'm going to do is I'm going to put the vertex positions in fbuff, which is a 4096 float buffer, or actually maybe it's just 1024. Either way, it's easily enough to store a line. So we're going to set the vertex position, and it's just going to draw directly. Yeah, I need to transform the positions to camera space, and I'm just thinking is there going to be any difference between 2D and 3D? I mean, I'm going to need to divide the view distance unless I change this to do view space Z. So it's divided by view distance and normalized. Then it would be compatible. Hold on. Are they compatible? I don't think so, because one takes in XY, yeah. Never mind, they aren't. This isn't going to work for what I'm thinking about. So, never mind, we're fine. How am I going to do this, though? Or how am I going to test this? I might just do this in like the soft body example. No. So what we're going to do is we're going to do 3D, because this is what I can actually test in this example. Okay. Oh, I could just copy the arguments in like this, I think. Let me see, would that actually work? Typed array dot set. Set from input values. Okay, this should work then. fbuff.set arguments, and then we should be able to do 3D mesh.set data, I think just set, fbuff.slice 0.06. Is that correct? Offset and end? Yeah. And then I just need to check that this is also yeah, set. Okay. And this is actually dynamic, so we'll set dynamic to true. Maybe it should actually be stream, not dynamic, because dynamic draw, there's also stream draw, right? If it's just going to be drawn once, that's what this is. Hold on. Is that a thing? Static draw. Specified once are intended to be respecified repeatedly, used many times. Contents are intended to be specified once and used at most few times. So yeah, we actually want stream draw. So I should actually change this to take in usage, because you actually want to specify usage. And then I'm going to need to go through and actually change anywhere where it sets meshes now. Okay, time for some refactoring. There we go. So now we can specify GL stream draw. So that sets up our mesh. Hold on, I'll be right back. I'm going to get some water. So I think this will bind the mesh. So it'll already be ready for rendering. So we need to bind the camera render texture. Oh yeah, we need to convert the line positions from world space to screen space. Yeah, so I actually can't do set arguments. I should actually be looping through. And transforming them each one by one. So I think it's proper to do camera.world-to-screen arguments v. And then this will output in an F buffer. Yeah, world to screen with the world Z, and then we divide that by the view distance. Okay. Hold on, I just realized min view distance isn't used for anything in the shader. I don't have anything that uses that, do I? Wait a minute. I'm not applying minimum view distance, am I? I guess that's actually something I might... When would I want to clip off the camera up to a certain point? That would almost always cause bugs, and you can always do the same thing by just moving the camera closer and increasing field of view massively. So actually, there's no reason to have min view distance, unless it's a limit on precision. I know it's something to do with matrices, but it doesn't happen in this, so I guess I'll just leave this blank for now. Actually, like, no min view distance. Let me just check. So this is like, okay, I already closed the shader, but yeah, like, so yeah, no min view distance. So what I need to do after this is fbuff2. Oh, so this will actually output to fbuff as well. So I need to like have an offset position in the f buffer. We'll start at 3, I guess. And then this Z we need to divide by the camera view distance. So I think this also affects the Z sorting is the main thing. As it affects how precise it is. Like I'm actually thinking if I actually moved the Z offset by the min distance, having only a 16-bit depth buffer in WebGL at times, this would allow you to have more. But I don't know. I think you're just kind of supposed to design around having a 16-bit depth buffer in WebGL. I think this is it though. I think that's all I need. It converts it to screen. Is there anything here that tells us if it's the one thing we need is for it to be off screen. I guess the negative Z does that. So it should still clip off screen. Alright, so that should set our mesh. Now I'm just thinking, I need to set uniforms. We need to bind our shader. Yep, so the uniform location should be in a variable that I can just access in debug draw, going like GL uniform 4F. And then I think just C like that? I don't know. I guess I'll do actual color. And I'm gonna do green to begin. Oh yeah, and then I'm gonna need to enable alpha blending, depth testing. Or maybe I should leave that. Like maybe I could leave that as an option actually to the rendering, to whoever's doing the rendering. I can at least do set blend mode, I think. Should I enable depth right and all that? Huh. To enable depth testing? And I'm just going to leave those options up to whoever's doing the rendering. So then I think all we need to do from that is just GL draw arrays, GL lines, and then however many vertices are in this mesh, which I think is 2. And I'm actually going to do the colors in a variable. Alright, that should be our basic draw line. So I believe I should be able to add this along with my options like blend mode, depth testing, debug draw 3D line. Alright, initialize that with the camera. I believe we need to add debug draw 3D to the build. We got an error, that's not unexpected. Oh, I never did the full debug draw line. Let's make it go -1 to 1. And I'll make it green. Error mesh.data is null. Oh. I didn't design this properly. Well, first of all, it is supposed to have set data, so that is bugged out. Something didn't set there. I'm wondering, where did I create my own mesh? New mesh. Yep, I did create my own. So, yeah, I need to add some value so that if the mesh data isn't still in memory, and I'm actually going to add an option, I think, to do that, because wait, I think I unload the images. Source image equals new image. The image isn't saved at all in the asset. When the image is loaded, yeah, it just actually loads a texture. So that's actually what I want to do for the mesh, is I want to have a way that you could just throw away the mesh data from the CPU and just have it on the GPU. And this current system actually wouldn't support that, because because I have it set to read the mesh data, or the mesh data length, for rendering in Scene 3D from data. Here I do mesh size, but that's actually bad. Yeah, indices.length. I just need to store index count, not the actual indices. And then when it sets the data, copy that over. So I'm going to do that right now while I'm thinking about it. Vertex count, index count. And was I stupid enough to check if, oh okay, no, I did have a check for element array buffer. Nice. So when I set it, this dot vertex count equals data.length minus elements per vertex, or divided by elements per vertex. That gives us the exact vertex point count to render with GL draw arrays. And then we need to do the same for index count. So that way, if there's actually no indices, we can still render it. Just do index count, and then here we do vertex count. Beautiful. So that should work. Okay. Okay, very nice. It's not drawing the line. I'll have that debugged. I'll disable all the other rendering so that we can maybe see the line. Let's disable the object. Will not spawn a particle. Now let's check this. Debug draw, 3D line. Maybe we'll turn depth testing off. Depth right off. And I think I should probably have it debug the F buffer when it renders this. Okay, this should print out the 6 vertices of the line. Oh, I forgot to convert from world space. Or sorry, it's in screen space but non-normalized. I completely forgot that this is in pixels and OpenGL is in normalized, so I need to do X scale is dependent on the render texture X. This way we can just do it with multiplies. And we're going to scale this by 2. Subtract from 1 because OpenGL viewport goes -1 to 1. Alright, this should do it. Okay, those values do look correct. Maybe it's just not setting the uniform value correctly. I might, yeah, could definitely be doing this wrong. No, it seems like I'm doing this right. Uniform location. Let's check. I need to maybe set this up to just output once. Actually, I just realized I don't need to output that to console to debug it all the time. What was I trying to debug there? Oh yeah, debug draw 3D shader. Yeah, so it's got color, uniform location. So it definitely sets the uniform. So let's see, negative 0.04, 0.1, positive Z in both cases. As far as I'm aware, it should be rendering. WebGL GL lines not rendering. I wonder if it's cull face. Wait, so what if I do set cull face? That do anything? No. WebGL not drawing lines. Supposed the number of lines to be rendered. Oh, I guess I'm just not binding debug draw 3D mesh dot bind. I guess I literally just have to bind. I think I literally just forgot to bind the mesh. No, it wasn't that. According to that, the line should just be in the center of the screen. Yeah, and setting the array buffer does bind it. What? So it was already binded. Draw arrays, GL lines, 0, 2, use shader, bind render texture. So according to this, GL lines should actually just be drawing on the screen. I wonder if there's something about the render texture binding that's off. I don't see how that would be any different than this, though. And like the world to screen is obviously good because we can see the values it's generating for the mesh. It's almost like GL lines just isn't being rendered. WebGL GL lines doesn't work. So let me actually check this. Line width, is this documented? So if the minimum and maximum width is implementation defined, the maximum minimum width is allowed to be 1, the minimum width is also allowed to be 1 because of these unimplemented. It's not recommended to use line width other than 1. Oh, I know why. I think I need to call camera.render before draw a line because it clears it in camera.render. There we go. Okay. Let's check what changes anything. I don't think culling does anything. I don't think depth right changes anything. Alright. This is nice. Now gonna enable our rendering. Oh, but our line actually is bugged. Our line is bugged. Something about it isn't rotating correctly. It's almost like the line is rotating opposite to the camera. I'm not certain. That's kind of hard to tell. Maybe I'll try expanding where it draws farther. Yeah, it definitely looks like the line position is moving as I move the camera. Why is it doing that? I know the point to screen code works fine. Okay, that is huh. It didn't do that before. Wait a minute. That shouldn't be happening because when it calls scene 3D, it calls material.bind, that should call set depth right, and that should reset. Or is this whole thing just bugging? Like, setting the options here shouldn't do that. I think I might have found a bug. Depth test, blend mode. That's really weird. Alright, it's all good. What if I change that? Does that affect... No, so blend mode gets set. Does depth test? Depth test greater. No, that works. But something about depth right here. It never resets that back. Why? Set depth right. Current depth right equals dw. Depth mask. Wait a minute. WebGL depth mask never turns back on. Oh. Oh, I think this has the effect of never clearing the depth buffer. It doesn't. Oh, that's super interesting. So it doesn't clear the depth buffer if depth writing isn't on. That's actually really stupid. So I actually have to add something in my code here that will turn on depth writing just for when it clears depth. Otherwise it won't clear. It's kind of scuffed. WebGL is weird, man. Okay, this should actually work now regardless. Yeah, perfect. Still though, it doesn't explain why this draw lines has some wonky stuff going on. Maybe I'll draw another line. I'll try to start drawing a box maybe. Alright, that should draw red and green lines. Yeah, like goalposts. So you can see it actually works, but then it starts rotating. What's going on there? I wonder if this is the homogeneous coordinate. Or else the screen might not be working 100% perfectly either. Yeah, so that one goes higher than that point. It's closer, and that one goes higher than that point when it's farther away. What's going on there? I don't understand how that isn't also happening for these objects on the screen. Oh, so the Y is flipped. That's one thing, but that's not... That shouldn't change anything. Okay, they're not rendering now. What did flipping the Y here do? Oh, this needs to be +1 now? Wait, did that just fix it? Oh my god, it was just flipped Y. There we go, debug drawing. Woo! So now let's try it with depth testing on. Nice. Okay, now I want to program it so you can do multiple lines. Actually, I think I'm just going to keep it as simple shapes. I don't know, I feel like, like if you want to draw a lot of lines, you'll be smart enough to do big set of lines. I don't know, let's... Let me think about how I'm going to design this. I can't remember what this type of functions is called, where you can just call the function and you don't need to worry about OpenGL state or whatever. So I'm going to create one that just lets you pass your own array. Yeah, see, this is weird because you'll be applying the same screen space modifications yourself. I wonder if this should actually be connected lines. Like, should it be all lines that form a closed loop, like a line strip? Hold on. straight line to the next vertex. Connects the last vertex back to the first. Okay. Yeah, so I'll have two different versions of these, one for lines and one for line strip. And this way I can have basically any number of lines. This is very nice. Let me just look at how this would work. I can't... Okay, never mind, I figured out how this will work. Okay, so that should draw a line strip now. We're going to do the same but for lines. I don't know if I should even have those be two different functions, because it's really identical. So line strip. If strip that, else do that. Okay. Nice. So now we got one debug draw 3D lines function, and we can actually do this for all of our other line functions now. So this debug draw 3D lines can now just turn into a debug draw 3D lines call. I just need to pass the arguments to the F buffer, slice that. I think, hold on, I wonder, can I set buffer data to a float32 array? Or, sorry, does it have to be an array buffer? Yes, so source buffer has to be an array buffer. Alright. Float32 array. Okay, perfect. Oops, wrong button. So let's see, fbuff set. To set it offset by 3, and I actually only want to set it to the arguments to the first 3 arguments. I might even just do this. And then debug draw 3D lines, fbuff slice. Alright, so this should draw a line still, or draw lines. No, okay, it's broken. Interesting. Interesting, we broke our own line drawing function. Nothing like breaking your own functions. 5 by 6. Through. I guess I can look at what the mesh is. I actually wonder if it's just straight up not rendering, because the data right here says that it's on screen. Data here says that the lines are on screen. So I think either way these are actually NL divided by 3. I think that's actually my issue. Yep, that was my issue. Okay. So now that we have this debug drawing, I'm going to go through and make actual primitive shapes. I'm going to start with a cube. I think I might do a sphere. I think I might do a cylinder. So now this is similar, but we actually need to take our center position. Yeah, I'm just thinking about, I can render this with a line strip where I actually go through one by one in the order of the cube. I think I'm going to do that and go through one by one in each line, because it is you know, I'm just thinking if there's any easy way to actually calculate that. Hold on, I'll be right back. So this fi is going to be where I'm outputting to the buffer currently. Maybe I'll just make it I. And so I'm actually just thinking if I can do this in a for loop where I go around the 4 points, go around to the other side. Or if it's actually easier if I do it one by one. This is actually kind of a fun challenge. Let's try and fit these together. So I'm going to start at the bottom left. Yeah, there must be a way to do this with for loop. With a for loop. What if I did 1 point going forwards? That would still be a pretty big for loop, at least what I'm thinking about. Yeah, I actually think me just writing this out by hand might actually be as easy. I'm curious, I kind of want to write both of these just to see. Man, it's really starting to look like fall outside. I love it. It's getting pretty. It's got that fall vibe. Okay. So our base point is our position time plus the size times the direction. I think I can actually make this pretty efficiently now that I've thought about it a bit. And then we just need to loop through to the points that are the 1 point to the right, the 1 point up, and the 1 point back. I believe. Nope, that actually won't fill in all the points. Huh. Hold on, this works in my head in 2D. And I know it works, actually I know for a fact this works in 2D. Let me draw this out. Okay, so now in 3D, no, yeah, it doesn't work in 3D. Unless I'm missing something. No, yeah, it doesn't work in 3D. Interesting. Yeah, I actually feel like me just like doing this point by point is actually just the easiest way. Alright, bottom left. Bottom left back. And then we're going to move over to the right. I'm trying to think about how to do this without wasting lines. Yeah, move over to the right. I should actually store these values. Here we go. And now this is way easier. Or makes way more sense when I write it out. Okay, and then we're going to go back to 1. I think we're going to go back after that. Or maybe up. Okay, let's go up. Alright, and now I'm gonna output this to test. Because we're gonna need to make sure that this is all working properly. Oh, and I just realized I should also have rotation for this. Ooh. I should actually have rotation. Maybe I'll do a second one for being rotated as well, because then it's got to apply a bunch of transformations. Yeah, it'll actually have to do it differently. No, okay, I'll add that afterwards, but that will be something that I do. It's not rendering. We got 9 data points. Looks like it's on the screen. Why is it not rendering then? Oh, I did color B twice. So left, right, up. And then I think I want to go back now. And then what do I do? Then do we reverse it? Left, down, back. Maybe down. I was thinking about ways to not revisit the same lines, but I don't think there's any way to do that. I think you have to pass over one. We still need to loop back there. Go across there. Yeah, I actually don't think line strips are a good way of doing this. Because I'm going to have lines going back across each other. Huh. And then at least if I do it in a for loop, I can implement rotation really easily. I'm actually thinking about doing the sphere as well. I feel like rotation could actually be used there as well. Huh. And rotation, yaw, pitch, roll. So I'm just thinking, like, how I'm thinking connecting lines backwards is the way to do this. Yeah. Oh, Hold on, my cat is ready to go out or something. I'll be right back. So whether or not it goes back connecting a line here is whether or not these are one or not. I'm just thinking if I should separate the cube into the 6 points first, or 8 points. I mean, that would be more efficient, but I'm not really doing this for efficiency here. So yeah, no. Yeah, so I was saying I was going to do this in line strip. I'm just going to do this with lines. And I'm going to need to do a rotated point here now for it. Oh, hold on. Alright, so now whenever I need to connect lines, I'm going to be adding this line and then whatever I want to add it to. So Lx is going to be negative x. Yeah, I definitely feel like I should put these points in a buffer first. Huh. Huh. Whatever. So this is going back negative on the x. And then I'm just thinking we gotta add x to that. Y here. We need to add the actual transform offset after we do the rotation. Okay, and now we repeat this for the y and z, and this for loop should do the trick for us. See, okay. Hopefully this will draw our box. Error, px is not defined. Oh. I renamed it rx. No, wait, never mind. I do need a px. Okay, so it's there, but it's not rendering. It is there, but it is not rendering. Oh, it's because I haven't passed in any yaw pitch rule yet. Wow. So there's our cube. Okay. Let's actually try rotating this. Beautiful. Absolutely beautiful. So let me try just adding one more primitive. Let's add a sphere. And then I'm gonna do 2D debug drawing functions. So for this one, I think I'm gonna, there's multiple ways I can do this. I can spin around from the top to the bottom in set rows, or I could spin around continuously. I think I'm gonna try both. And also I want to count constantly how many. Oh yeah, I believe this is 72, so this should be 75. Yeah, that should be good. So let me see if this is 72 in length. 72 plus 3, 75. The exact. Yeah, so this is the exclusive end. I think that's correct. Hold on. I'm just going to debug and just make sure that this box is the right value. 75, yep. So now we're going to do the same thing but with the sphere. Oh! Hold on, this is a good time to check this out. I've been meaning to switch this since the bot started attacking. Hold on, that was actually really good. The bot actually just deleted that message before it even showed up in chat. Beautiful. Let me see. Alright. Should have less trouble with bots now, I think. So, what I'm going to do with this is I'm going to slowly loop. So this is the thing, you got an X and a Y, and you got to repeat those going downward. I'm thinking of just doing it with a single variable like this, as like a line strip. So the way this would work is sine or we need one of these that goes pretty quickly and another one that spread between the whole loop. So this should make the points rotate down the sphere, spinning like a sort of cylinder. Actually, why am I doing rotate? I don't need to do any rotation. Then I just write out these points to the buffer using the offset plus radius scale. Easy. Okay, let's see how that works. Yeah, so that is actually kind of what I'm talking about. Except it should start right up in the center. Oh yeah, this whole thing is scaled by the Y. Oh, and it needs to go up to pi, so you can go to 314. Oh, and that makes it loop back around. If I don't do abs here or something like that. Actually, I think I need to do the inverse. So that's weird how it actually goes back down. Sine. So what happens here is it goes up and then it goes back down, which kind of makes sense. It goes through the whole sine. Let me just try multiplying this by math.pi. Let's just see how that works. So pi times 2. I think it's supposed to go farther up than this. Might be wrong, but I think it's supposed to go like twice the height. Maybe start at -100. Yeah, there we go. Okay. Alright, that's similar, but that's not actually in the shape of a sphere, or is it? How did I make a sphere shape again? I think it was like atan. It's the same as making a circle here. Fill circle. Cause a sine. Just looking, maybe make this rotate less across the X. I don't know, what would that do? No, actually it needs way more rotation across the X. There we go. That's nice. So I definitely need to like increase the step of the lines across the Y so it doesn't have the bias right here. I definitely think I'm going to separate the Y and X so that I can do this same thing that I do in this rendering where I go across the Y and then calculate the X cross section from that. Although kappa votes, I'm setting up a debug drawing system for my game engine that draws a bunch of primitive shapes like boxes and spheres out of lines. And I've got boxes and lines all done. I'm just doing spheres now. Cool. What about the physics system? Pretty much finished that now. You can see the ball bouncing around here. We did mesh colliders today, which is this terrain mesh it's colliding against. It's really slow right now though, so part of the reason for this debug system is going to be working on bounding volume hierarchies, like octrees, some sort of optimization structure for the mesh. So we're still kind of working on the physics system, but need this debug drawing will help the development a whole bunch. And yeah, this ball bouncing around actually should stop eventually. Like get stuck in a corner here, it'll like hit right on a corner or something. The physics stuff is right here. This was the haven't even commented the collider mesh really. But this is the code. I'm still thinking actually about this. I've got the same code copy and pasted twice right here, or it's basically the same code. There's just one little difference. It checks for the smallest distance and then adds up the normal, counts up the normal while it's doing the distance, so it's like a tiny bit slower. So I'm like, I feel really bad just copy and pasting the exact same function twice, but it's not the exact same function. So to my brain though, the one little difference still makes it the exact same function. Alright, so this is nice, because now we'll just get constantly sampled Y.
I am impressed.
Hey, thanks for the follow, Kappa Votes. So I'm just seeing what we do here. This Y is actually going to need to be scaled by radius. And then I need to loop around and do the X and Z circles that make up the sphere on cross. Makes up the sphere by doing cross sections. I think I want to increase the resolution of the cross sections as it goes up. Like right now you can almost see that it's like it's the same resolution up here at the top as like in the middle, even though in the middle it needs like way more resolution because it's way more stretched out. Like the mesh density is way off. It's funny though, this debug drawing stuff, it doesn't even matter if it's optimized, but I'm still like, I want to optimize it. Alright, so this circle iterations is going to be based off this ny. It's going to do like 10 minus, or I don't know, 6 minus ny. Don't fall into the trap of premature optimization. Yeah, no, not at all, never. Never do that around here. Now the shit that drives me crazy is when I spend like a day optimizing something and then someone comes in here. So this is a legit thing that happened the other day. A guy came in the other day and he was suggesting to me how to make my shader more optimized, and the guy had no fucking idea how shaders worked. Like, I cannot, man, it's one thing I just can't stand is I don't know how to react to it, man. Like, I'm just like, I just want to say you don't know what the fuck you're, but at the same time as a streamer, I'm like, you don't do that. But I'm just like, yeah, sure, dude, that's awesome. I actually said to him, I was like, okay, thanks, maybe I'll make my code more optimized. And then I just like kept on with what I was doing and just ignored him, but it was like, huh. No, I was like, his suggestion was to run my shader like 10 times more, which I think like anyone who knows graphics programming knows. If you, he basically told me to do 10 times the draw calls, and I was just like, that's not an optimization. And he was like, you didn't even try it. And I'm like, no, I didn't, but goddamn. So like here's basically what I'm saying. You can if you give me advice, it's fucking awesome. But if your advice is bad, I'm probably going to call you out on it. Which I mean is, it's kind of a funny thing. Like, people come and give you advice and they're like, take this advice, I'm helping you. And then you're like, this is shit advice though, what do I do with this? And they're like, I was just trying to help you, man. Alright, I need to stop talking about this and just, I'm like just about done this. This might have a gap. I'm not sure. We'll see. It's really people regurgitating what other people told them. Yeah. I have a saying I think that's similar to that, is that if you think you created, so this is actually a math thing or a shader thing, but if you come out and say, oh man, I just invented this insanely new algorithm, no one's done this before. Some mathematician in fucking in Greece 800 years ago, he did your algorithm on a piece of paper. So it's like, even stuff that people like, it's not doing something new or like fresh isn't amazing. It's just like, it's like, yeah, like I think understanding it is more important than just repeating what someone else did. Because like, that's the whole thing, is like, in my opinion, like, some of these amazing things in math have been figured out years and years ago, and people just forgot about them. People just didn't use them because we didn't understand them. But I'm like, a bunch of people think that those few people that did figure them out, the few years, like years and years before other people did, like, it's like, it's not repeating them that makes it useful. It's like understanding it. Okay, this should make a cylinder. Oh, it's a half cylinder. Interesting. It's like chopped off in half. Huh. I think pi times 2. Okay, now it's kind of janky. I don't know, let's... Wait, how many, Oh, I think there's 100 points in the line, which isn't bad. So what I need to do to make this a sphere is I need to scale down these lines at the top based off this value. I haven't done this math for a long time. It's like, what exactly is this math doing again? So this is taking the y position, finding the radians, the approximate radians using asine, feeding that back into cosine to give you the radius at a point. Okay. Math, you know? Now let me think, is this normalized? Yeah, this is 0 to 1. So my ny is good. I just scale that by radius. I use yrad instead of radius here, so this should be good. Let me just check my math. Math.asine 1. It's 1.5, 0.5. Okay, this should work. Maybe, actually, what does 1 give? Okay, this might work, it might not. Oh, nice. There's our sphere. I think that's alright. That's actually pretty good, I think. I feel like I need some more lines going at this angle, but at the same time it works alright. Maybe if I did one more line up here. What are you, a student? Or no, I have no... I've just done games, so I actually started hacking games. It's actually, when I say I'm a software developer, I mostly break other people's software. And like, I've talked about this before on stream. Dude, you're actually not allowed... I've seen some people stream game hacking. That's so fucking illegal. People are idiots, dude. So the one thing that's illegal is redistributing intellectual property. If you open up another game's code on your stream, and you're not like one of the developers or one of the people from that company who has a license to redistribute that, I'm surprised people haven't been sued for that shit, but like, it kind of makes sense because the game companies only go for the people who actually like distribute hacks and that stuff, but like, dude, it would be so cool to be able to do like game hacking streams. Although it does make sense because Twitch has like zero tolerance on doing hacks on streams. Like if you're hacking a multiplayer game on stream, it's just like, that's the really interesting line, is where does the line even get drawn? Because if you make a hack for like single player in a bunch of games, it applies to multiplayer. But yeah, if you watch this stream for a while, you'll figure out I actually like math a lot more than making games and things like that. It's kind of bad, but it's the way it is. And that's also why you see me developing an engine instead of actually making a game, when like I know how to use Unity and all that stuff. Alright, let me try increasing the number of lines at this top part. I don't know if that necessarily made it better. Okay, so at that top part, oh, the radius is 0. Oh, never mind. I'm happy with the way I have this. Happy with this. This works. Alright, now I just need to do this for 2D. So I don't know if I'm just going to copy and paste and replace this or what. Legality is complicated. Math is cool. Taking an abstract algebra course that's making my head spin. That's part of what I hate theory and math. I think like so the point in my opinion of like math and like the language of math and representing it as equations, it's you trying to take that imaginary theory and actually turn it into a real construct that you can share with other people, because that like logic of using the same language lines up with other people. And I just fucking hate the whole idea of theory and math, of like people doing stuff without, it doesn't like it doesn't fucking work. Like you get a bunch of shit that's like, this works provided that all of our imaginary conditions are met. And then you go and try and like, so as a programmer, I'm like, I see all of this math stuff that you try to actually program and they're like, oh, that's just impossible. You need infinity. Like, oh yeah, we've just got pi, but we don't actually have pi, just the first trillion decimal digits. But like what you'll see in math, the joke about that is what you'll see in math is people are like, oh yeah, just use pi. Well, it's not actually like, just use pi. You just replace pi with like the symbol of pi, and then you can fit this infinite value into a symbol. That's not how it works. Just because you theorize that that's how it works, it's not what happens in reality. I suppose there's a dividing line between pragmatism and theory, but I think too much pragmatism is unhealthy too. I don't know. I come from the weird land of programming where I just called derivatives differences in subtracting for like, I still call it that. Alright, hold on. Oh, the sun is getting very bright. There we go. Just gonna get some darkness for a few minutes. Maybe I should just get sunglasses. I saw a guy who streams in sunglasses, now I know why. Does Kit Boga still stream in sunglasses? Alright. What's different about this? I gotta do plus equals 2. It's a 2D camera. So how is world to screen different? There's no Z. Okay, there's no Z. Space points. Should I all give them a Z or... I think it'll be obvious to people that Z is used for depth testing. Like, you know how game devs don't care about big O notation? I think that's wrong because big O is a good estimate. So what I've seen a lot of these days is that because you're using an engine like Unity or Unreal, the like algorithms that it comes down to actually evaluating for the majority of the simulation of your game, like the physics, it's not actually up to you. So a lot of the things where big O actually matters isn't even under your control as a game dev anymore. I'm just looking around, I'm like, fuck, I left my water. I left my water in the kitchen. I'll finish this and then I'll go and get it. But yeah, I agree. Big O is like, it's like, isn't that like just like the, hold on, what is it big O actually do? I might not even know what I'm talking about right here. Mathematical notation that describes the limiting behavior of a function when an argument tends toward a particular value or infinity. Oh, runtime or space requirements grow. Yeah. Yeah. What does big O specifically mean? Man, one thing I hate about big O notation is how fucking like you can have functions that literally like the function that defines your big O notation could be more expensive than the function you're defining the big O notation for. Anyways, I think big O is really good when you can do like O(n) to the power of 2 or like log n, where it's like an actual understandable scaling or curve. But then if you get like O and then the function inside is a neural network or matrix that's calculating some black box, it's like, thanks, that's helpful. Alright. Draw line should be the same. I didn't think I was going to debug these, but you know what? Seems stupid to do this and not debug. So let's just take one of these. Is the sun gone? Oh no, the sun is still... Let's see if I can get to a decent... It's alright. Alright, so I'm just going to add draw 2D. And I'm just going to go into the rendering code here and we're just going to add debug draw 2D line. I'm just going to draw a line like straight across the scene just to test this. So this should draw a green line. Debug draw 3D lines is not defined. This is why we test stuff. Debug draw 2D camera is undefined. Alright, it's not rendering. Let's just make sure depth testing's off. Blend mode is on correctly. Okay. Might be actual issues here. So what's happening with what I'm thinking? Depth right is off. Depth test. Oh, wait. Depth test is on there. Depth test is off here. Okay, so there's definitely something broken. Let's look at the mesh data. So we've got X, the Y is off-screen value. Okay, hold on. Why is the Y off-screen? What is happening? I guess it's something with... That's 2 divided by width. YS... So this is converting to normalized coordinates. The world to screen, as far as I'm... Oh, wait, is extrapolate on? Hold on, could it be because extrapolate is on in this example? No, there's no extrapolation here either. World to screen. Oh, I'm doing fbuff2 when I don't need to do anything here. Oh, that still didn't do it. So yeah, 0, 0. The Y is off screen. So what am I doing? So this should be -1. Okay, something is broken about this function. Something is really broken. Unless... I actually don't understand. I cannot figure it out. Why is it warping it? See, the Y is at 2 and 1.95, which almost makes me think it's warping it by the camera or something. X times field of view, inverse field of view, which is 5. So that scales it down. That explains the X right here. Y times field of view minus cam Y. Aspect minus 5 times height. Huh. I mean, maybe it's something about the inverse. I don't know, I'm thinking maybe let's try not doing any conversion. What's this data like? Yeah, So the y is negative off screen somewhere. 580 to 784. So the x is correct. The x is going here to here where it should. Why is the y clipping up off the screen? Just going through and slowly rubber duck debugging it over and over again. Maybe I'll need to step through this one by one. Debug the position after the rotation. 2, -2, -2, 2, 2. That's all correct. So something when it does the aspect ratio here. Let's see, times aspect x. Maybe I'm supposed to divide by aspect x here. Oh, I divide by aspect x in this one. I think that could explain it, because I multiply by aspect x here. $500 to $800, -42, -405. It's still off screen. It's so weird. So let's see, if it's bigger aspect x, then it'll divide, reduce that. If it's bigger. Am I flipping that at the wrong? Oh my god, I think I was just rotating it wrong. Or I was flipping the y. And then, yeah, I was flipping and then I thought I was like inverting it. Okay, hold on, let's see if this works now. Okay, there we go. There's our line. Yeah. So let me go and program the other 2D functions now. That was really stupid of me. So the issue is actually in my whole scene 2D code, where I converted the world to the screen. First of all, I didn't divide by the aspect ratio. And then when I flipped the y, because y to the screen goes up, when you do it at the other part, it goes 0 to 1. and you flip it by doing negative, subtracting afterwards. But then here, it's going -1 to 1, so just scaling it by -0.5 just inverts it, and you don't even need to flip top to the bottom. Man, math is hard. Math is hard. Okay, now let's do a box. Using OpenGL, so this is WebGL and JavaScript. Yeah, it's based on OpenGL ES2, like the oldest version of OpenGL available, but it has shader programming, and you can do pretty much everything you need. I've just got this graphics file that has meshes and textures and stuff wrapped into nice classes. Oh, I just realized I can change this from I to 103. I think I'm just about done. I just need to make this box. This is actually a huge waste, the way I'm generating this box, but I mean, whatever. Like, I guess I could calculate these points one by one manually, and it would actually be just as easy for this. Let me actually think about doing that. I just did this for loop for 3D because there's a lot of points, but for 2D, I think this will actually work, yeah. I can just do a line strip for 2D. This is actually way easier. So I'm just doing the 4 points of a box right now. And I just realized I can actually copy the same values from back here . Alright, wait, so then after we go to the width, we go up. So then right here we do y plus h. And then this one's going to be the last one. Oh wait, no, second last one. Now we do x minus width. And then for this last one, we just copy all the ones before. So this should be 16 points. Oh, I just realized this isn't going to rotate. It's not going to rotate any of them. Okay, so I'm going to rotate all the lines. So we just need to do rotate 2D on these. And I'm just thinking we actually need to not add the offsets to these because you can't do transforms before rotations. I just realized there's no length. What am I doing here? Alright, now I can add the offsets. So that does the rotation, then we copy the lines into there. Alright, now it should be ready. So let's try drawing a rotating box. Okay, interesting. I know exactly what's wrong here. I need to do true. Oh, that actually didn't quite do it. Wait, so 3, 6, 9, 12, 16, 19. Maybe this goes to 20. Let me see. Where are you residing? I am in Ontario, Canada. 18, huh? So why is this last line not drawing? Oh, this is supposed to be the first. There we go. Boom, there's our box. Now we just gotta draw a circle. Right now during autumn, no, it's been insanely hot still. Actually, so the forest fires all across the US, yeah, so regularly around this year, we're on the border. It's still like 30 degrees Celsius here. Like, that's down from the summer where it's like 35, but it's still really hot. Like, the sun is... I've started sweating since the sun went in my room. But, so the interesting thing was, the forest fires in the States, we got covered in smoke from those like 2 weeks ago, and the temperature dropped like 10 degrees. Like, have you ever heard of nuclear winter? Where like smoke and debris in the air lowers the temperature? It's actually crazy. That's what it made me think of. Like, the temperature just dropped all of a sudden for like a week. Which is actually a super scary thing if you think about it. That the fact that, like, could literally just go into an ice age or something. Alright, now let me do the circle. And 2D circle is way easier because now we just get to loop around a single iteration. I don't know. We don't need to do multiple segments of circles within circles like the 3D sphere. Alright, super easy stuff now. Just add our transform x plus the sign of the frequency or the current time component, which I have short form as frequency as well because time is constant, so it's actually just like frequency and time become the same thing. This is why some of the like names for math is kind of stupid. Frequency and time are the same thing depending on like what system you're working in. Alright, that should give us a circle. And I didn't draw the circle. Alright, now this should draw a circle. Oh, it drew a half circle. It's a very nice circle though. Very nice circle. Look at how smooth that line is. Except for the non-anti-aliasing. That you cannot fix in WebGL. If there's one thing that sucks about WebGL, it's that you can't do multi-sample anti-aliasing properly. There we go, there's a circle. Maybe I'll make it a little bit more precise. There we go. Very nice. And how many points is that? 63? There we go. So there are our debug box and circle and line functions. Wonderful. That's so useful for having in both 2D and 3D. Now we can basically at any point... Oh, what did I just do there? Hold on. Hold on. 63 plus 3... Is that not 66? Wait. I'm an idiot. Did I do the wrong thing? Did I actually count the wrong number here? Hold on, I might need to go back through here and check these. Double check them, because I just messed that one up. Currently learning about compilers. No, worked with low-level graphics. See, this isn't even really low-level. This is like... OpenGL is technically high-level, because you just tell it to draw lines for you, and it draws lines. Learning about compilers. Compilers these days are crazy. We went through this the other day on stream. I still need to go through it. This seems to be the future of like multi-platform, multi-architecture architecture disassembly. It supports ARM, ARM64, MIPS, PowerPC, WebAssembly, x86, x86-64. It's programmed in pure C. It's fucking beautiful, dude. So this is basically an assembler for like making compilers. It's based off LLVM. Where is the info? Does it explain where it is? It basically follows the LLVM architecture, where it turns all the code into a like an intermediate format. Is there anywhere where it explains how it works? Include capstone. See the disassembled binary code. So you can literally just pass in binary and it... Wait, SSA format? So Capstone also has another one called Keystone, and I'm not sure what the difference is. They have a really good explanation. So include Capstone 6 raw binary code to disassemble. They just gave some hex code. Declare a handle variable CSH. Initialize Capstone. Disassembly the binary code. To be disassembled its length. The fourth argument is the address of the first instruction, which is x1000 if we want to disassemble all the code. 0 and return the API gives back dynamically allocated memory. Prints out disassembled instructions. Does it say what the example outputs? Turn on detail feature. Yeah, these are all architecture independent. That's why it's optional. So I'm actually curious. It didn't say what this outputs, does it? Oh, here we go. RAX. Yeah, I don't know. This is like, it almost seems too good to be true. Like, basically what this means is that you can just go in Python now, or D, or whatever language your language of choice is, and you can basically parse through binary code automatically. Like, some of the stuff that this does is crazy. I don't even know how to describe it. Like, so the thing that I've seen this that brought my attention to this is someone embedded this in their own little kernel driver, and apparently it's really easy to embed into your firmware. or kernel, which basically gives you full control over like reverse engineering. I gotta pick this up at some point, I think, and figure it out. I just don't have anything to currently use it for. Like, that's the thing. I'm just like, there's not really much new analysis that I need to do, but like, that's the thing, is figuring out how to learn it and using it as like a base for parsing a bunch of assembly instructions like that. Oh my god. Saves so much time. Does it have any docs? What information are they looking to glean out of the assembly scene? Well, for this, it's PE executable header files, and like that's something that you might want for like a website, for example, that lets people upload executables. You might want to scan like the header file to find information about how big the executable is and what platform it's for and stuff like that. And so apparently Capstone also gives you stuff for parsing that. I can't remember. I saw someone say something about how it lets you parse binary. But that's the thing. I feel like until I use this, I don't really know what the hell it actually does well. But the fact that it's used by like everyone now, I know it's actually good. Unless you were to write an emulator for a CPU chip or something. Yeah, I don't know. Like, I saw someone make a debugger using Capstone, or talk about making a debugger using Capstone, and I didn't see what part that Capstone actually helped with that, but like, if it has debugger features, I want to know about that. Alright, now I'm almost done for today. I'm just going through. Oh, how did I just break this code? Excuse me? Excuse me? How did this just break? And this is why I go through and check it. Alright. Debug drawing is all finished. Very nice. I think that's it for now. I think that'll be it. Did pretty good progress on the engine, I would say, today. Like, the physics engine is actually done, as far as I'm aware. Like, mesh collision is the final thing. It's fucking weird for me moving my hand around. It's like a light hitting the sun. Global illumination. Like a light on my face. Simple brain, amused by simple things. But yeah, that was a lot of math this morning. But now that the mesh collision stuff is done, it's so useful. I'm going to be moving on to the visual editor, I think, next. But first of all, I want to try to optimize the mesh collision, and that's what this debug drawing was for. So we'll be able to go into that straight away next time. I'm still not sure how I'm going to do the optimization. I almost feel like I need to think about some more ideas, but there's going to be no perfect approach for that, as I talked about, because I think all of the methods actually introduce errors to the distance function, which is really bad. But we'll see about that. We will see about that. Anyways, thank you for watching. I'll be back streaming again tomorrow. Maybe even be on streaming tonight if I feel like it. I might actually want to finish up this mesh collision. If not, I'll see you around. I'm on Discord or Twitter. If you have any questions, I'll see you around. Have a good day, good evening, good night, wherever you are. Thank you for watching.